Hey, York.
Hey, Kevin.
How are you?
I'm doing well, thank you. How are things in the great city of Morgantown?
Oh, good when we're not underwater.
Oh, no. How about sending some of that rain our way? We're kind of dry here over here.
Gladly. I just wanted to say hi real quick. I'm going to bounce between sessions for a little bit, but I just wanted to say hello. So
Great. Good to talk to you. So who's going to grant me presenter rights and all that kind of stuff?
Oh, you're either Hannah or Cassie, the JewelNet people will be
right.
your moderators for it, and they're going to run basically the entire sessions. So looks like so sorry, I'm looking at which track are you? You're in A or B?
B.
You're in B.
B. Mm-hmm.
Yeah, it looks like Cassie's going to be the admin, so she. And then a bunch of people basically just jump in right at the last minute, of course. So
Sure.
Thanks for doing this. We appreciate it.
Oh, sure. Glad to do it. Maybe we'll actually get to be in person 2 years from now, right?
Well, we're gonna. I think the board is gonna. I think the new board is going to talk about a mid-year meeting, so we'll see if that can be in person.
Oh, okay.
So
okay. Yeah, it's been interesting to watch the conferences for this year, the ones that are still virtual and the ones that are going in person.
Yeah. Did you have any contacts over the lunch break?
No, I was not able to join then.
Okay.
How's attendance going? Or can you tell from?
We had about 120 people register for the conference.
Good.
Yeah, for us, I think that's pretty good. I think we had about 90 show up. So I'm kind of, it's not terrible, but I wish it was, I would have been happier if it was at that 100 mark, of course, but so far it looks pretty good. Like most people have joined in or will be joining in. I know you won't see people in your room until I guess like it opens up technically at 1:30. So you'll get a bunch of people all in all at once. So you don't have to start exactly at 1:30.
Okay. So is everybody going to be back on campus for the fall, as far as you know? Oh, you left. Never mind.
No, I'm still here.
Okay.
Yeah.
Good.
That's the word.
Subject to change. I know. Yeah.
Yeah. No, I know. You know, I think ready or not, the university wants to get everybody back in person.
Good.
I think they're still going to be a little flexible with certain things, but I could be wrong about that. I know my office, we're, at least from the university's perspective, allowed to be hybrid.
Okay.
So I signed up for that.
Yeah, sure. Why not?
I don't mind working from home. I wouldn't mind being back in the office a couple days a week. So I'm hoping my boss is flexible with us, but we'll see how that goes. But yeah, I know there's definitely a mix of people that are dying to get back into the office and get out of the house. And I'm almost there. Maybe another year or two of staying in the basement will drive me back to the office. But
Well, hello, everyone. Welcome to presentation track B. My name is Cassie Chin. I'm with administration. So give me just one moment to orient myself. I just jumped from the networking lunch over to this session. So give me just one moment and we'll get our presentations lined up. If you are one of the presenters today, if you wouldn't mind, go ahead and turn your camera on if you have one, or reach out to me in the chat if you need co-host abilities so that you can share your screen.
I do. This is York Grow.
Hi, York. Okay, York, give me just 1 second. Very good. All right.
Yeah, this is Sheldon LeMay.
Hi, Sheldon.
Yeah.
Hi, I'm Jackie Strager.
Jackie. Playing Zoom whack-a-mole to give co-host abilities is so much easier when cameras are on. And I can see mouths moving and all that good stuff. All right.
Hey, Cassie, this is Merrill Friedrich.
Hi, Meryl. Give me just 1 sec.
And Amanda Smarr, I'll also need them.
This is Mike Anderson. I need it too.
Certainly.
Hi, Cassie. Stacey McDaniel.
Hi, Stacy.
Hi, Stacy.
Hi, York. How are you?
Good.
All right.
And Cassie, I'll eventually need them later in the session.
Just do it now. Okay. So did everybody who need co-host and screen sharing abilities, did everybody get that? All right. If you get to your point in the presentation and you don't have the ability to do what you need to do, just let me know. Reach out to me here in the chat. I'll be here for the entirety of the session. But Kevin, if that's okay, I think I'm going to turn it over to you to get us started.
Sure. All right, well, welcome back, everybody. I don't have any prepared remarks other than hope you had a good lunch. Hope you were able to get some networking accomplished with some of our exhibitors and sponsors. And with that being said, I'm going to throw you right over to York, who will educate you on the happenings in his world and what's going on with things that we should be paying attention to.
All right, thanks, Kevin. And just to verify, you all can see my screen. Is that correct? Where it says Esri Field Maps? Okay.
Yes, we
Julie's
can.
nodding her head. Okay, great. Well, good. Well, I appreciate the opportunity to visit with you this afternoon. So I've kind of got two back-to-back sessions. This first one, we're going to talk about Esri Field Maps, mainly as it pertains to hooking up with a GPS receiver. I have a few PowerPoint slides, but I don't believe in death by PowerPoint, so I will attempt a live kind of demo showing on my phone here in a moment, and we'll hope that goes well. But certainly appreciate your time. Feel free to use the chat window or just unmute yourself if the attendees are able to do that. I'm not sure if they are, but I'm happy to be interrupted or ask questions. From my perspective, this should be pretty casual, as if we were in person, where it would be pretty casual as well. So thank you all. So I assume that most of you all have heard that kind of Esri is transferring their collector Survey123, the whole mashup they've had of different apps, over to this thing called Field Maps. So they released that in beta, I think about a year ago, and have been working to kind of compile those and bring them into one app called Field Maps, so that it brings a little more simplicity to knowing what you need and then how that is laid out. So collector Survey123 workforce has been implemented in the past for work management, for work orders and things like that. Navigator, they're still working on from navigational capabilities, turn-by-turn directions, as well as a crow flies, needing to find where things are. Explorer and Tracker have a couple of different unique capabilities, but so they really combined all that now into one thing just called Field Maps. And now it's really varied based upon roles and not the actual apps. So you purchase or assign different people, different roles, depending on what you have them needing to be able to do in the field. So simpler from that perspective. From a purchasing perspective, you purchase whether you need viewer or editor or field worker or those various different nomenclatures now for the different levels, lets you access what you need to be able to do in the field. So now actually I'm going to switch over to my device here and show you a few things about Field Maps. So it's all just one app now. Instead of having to log into a bunch of different apps, you have this one app called Field Maps. One thing I would mention is, Esri has told us don't try to run collector and Field Maps on the same device. That doesn't work well. From a demonstration perspective, I've been doing it that way because we still have a lot of clients still using collector and not using Field Maps. So I've tried to keep both on my device. That failed today. So I actually ran into an instance where I had to switch over and uninstall my collector so Field Maps would work properly. So what I want to talk about is the GNSS component. If you all don't know, most of my background is with GPS receivers and making those work for different workflows, whether in utilities or planning or natural resources, whatever that line of work is. I'm with a company called Duncan Parnell. I guess I didn't give any introduction of myself, and so I should have done that first. I physically am over in Virginia, close to Lexington, Virginia, and we'll make some comments about that in just a moment when I show my screen. But serve the general region, West Virginia and the western part of Virginia with different GPS solutions, and have been around for a while serving this area with this technology. So the thing to remember when you want to use Field Maps with a GPS receiver, the biggest concern is making certain that coordinate systems match. And that was always the case with collector and continues to be a Field Maps, but now there's some different things being able to do with elevations. So different GPS manufacturers have different ways of managing that connectivity. I'm going to show you one example, but the same concepts would be true of any GPS receiver you're doing. And typically, we see this thing called high accuracy GNSS. Well, high accuracy means different thing to different people. From an Esri perspective, it really means anything that's not on the phone. So anything beyond what the phone might give you, they call high accuracy. From a practical perspective, from that definition, that means anywhere from 3 to 4 feet down to an inch or so, depending on what your needs are. And so some of these concepts that I'll talk about apply at all those levels. Some of them we really only need to be worried about if you're trying to chase the several inch capability. One comment I would make about elevations or getting that height or an elevation value into your map, you have to start out with making certain that your feature class is Z enabled. And that's something we run across with our clients frequently, is that they don't have their feature class Z enabled. So it doesn't matter how good your settings are with your GPS receiver. If the feature class isn't set up to absorb that, then it doesn't really matter. So I now want to show you just a few things. I'm going to move a screen over. So I'm actually displaying the screen now on my phone. So just nothing fancy, just a Samsung Android type phone. The application I'm showing you right now is called Trimble Mobile Manager. And that's a controlling app. There's no cost to it or anything like that, that is used for Trimble receivers. Other manufacturers have other apps that do similar things. So at the sub-meter, or I should say, at anything more accurate than half a meter or so, you're probably going to want some kind of app to control things in the background. Now, I'm showing you Trimble Mobile Manager because I can show you more here, but Esri and Trimble continue to work together so that there's things going on in the background that help this work. And I'm already looking at my time. I think I've got a total of 30 minutes for these two 15-minute sessions. I'm going to bleed some of my Esri time over into my TerraFlex time, only because I want to finish this conversation. So that works well for those folks already on this session, may not work so well for those joining right at 1:45, but I'll persist and I will pause for a second for questions because I do want to get through this, but I'll increase things a little bit. One thing I want you to notice here, so I'm connected, this app is connected to a particular receiver. This particular receiver that I'm hooked to is a centimeter level accurate unit. I can just see my lat long in here. Notice here I have both the ellipsoid height, which is what GPS automatically calculates, but then I'm also showing the orthometric height, which is really what most people care about. And this app enables me to calculate that and then to send that particular aspect into field maps. I can go here and I can show you how this was initially set up. Really what I want to show you is the position source. So that's where we just use Bluetooth and connect to the receiver. Now I'm going to go to my configuration. So this is where I set up my correction source. If I'm at the sub-meter level, you really don't have to worry about this because just using WAS corrections is typically what's done. In this case, I want to be using the West Virginia Division of Highways, the DOT real-time network. So that's what I have set up here. And notice this is set up within Trimble Mobile Manager, not necessarily inside of field maps. That's a little bit of a change. And that's also a change whether you're using Android or iOS. On iOS, it's actually within the Field Maps app. Within the Android world, we actually do those controls right here within Trimble Mobile Manager. There's still a couple of variants, but I'll talk about that in just a moment. So you can see all of my settings in here for the West Virginia GIS. Notice I do have the ability where, whoops, let me go back here, this GNSS reference frame. I want to make sure I set that up to NAT 83 2011. That's what we're out. That's what DOT is outputting for their network. And then down here, here's where I'm able to load the geoid. So the geoid is what gives me the ability to then calculate and push out the orthometric heights. Let me jump over now. Actually, this is where all the settings are done. And notice I'm getting down around an inch or so accuracy. Now, this receiver's been sitting out here a while. Again, I'm in Lexington. The closest base here is over in Lewisburg. So I'm about 60 miles or so as a crow flies from Lewisburg. So normally this is really tight accuracy, but mainly because it's been out, the receiver's been sitting out here for a while. So here I'm going to leave this app open like it is, and I'm going to go switch over to to Field Maps. Now, the first thing I need to do in Field Maps is to set up my connection to my receiver. In Android, there are two ways to do that. Notice right now my provider is integrated. That's because what I've done is I have set my location services on my Android device to be the Trimble R2. So that any app I'm using is using the R2 as its location profile. This is optional. I could, here is in provider, I could have connected to the R2. You can see it right here. There's no right or wrong way to do it. Either way is fine. If I want to connect directly to it here in Field Maps, I do not want to be connected to it in Trimble Mobile Manager. I can't do both. Personally, I like connecting the way I do because that way I can flip back and forth. I can see a few more diagnostics in Trimble Mobile Manager than I can see in Field Maps. But again, it's completely user preference. So I'm going to go back here. Notice I have a profile set up. This is critical. It is critical that you set up this profile correctly so that it accommodates the coordinate system coming in correctly to your Field Maps. Field Maps is always going to be in WGS 84 Web Mercator. So that's how you want to make certain that the Esri Field Maps is transforming your data into the appropriate coordinate system. I'll go back here. I'll go ahead and actually open a map so we can see what it is. And then I need to wrap up this session and make sure you see if you all have any questions. So I've got the app open. I can see different features I've already collected. I can see I collected a fire hydrant here, information on that fire hydrant. So I assume you're pretty familiar probably with Field Maps or Collector from the past. And then you can see my accuracy up here in the top, if I touch on that, so recognize that even though I have integrated selected as my GPS provider, it still knows it's a Trimble R2. So it captures all that information. And you can see there my altitude is reading in as the orthometric height, which is what I want. And then there's the various accuracies and things like that. It tells me I've got RTK fixed, et cetera. And it also tells me I'm using 12 of 27 satellites. A quick aside, because you're thinking, well, why can't I use 27 satellites? Currently today, the West Virginia network is only supporting GPS and GLONASS satellites. Hopefully at some point they'll upgrade so they can also add, especially the Galileo satellites and possibly even the Beidou satellites as well. All right, I'm about at the end of my first 15 minutes there, so I'm going to pause. Any questions or other things I can answer? All right. Anybody still awake?
Still here.
Hi, Kevin. I'm glad you're awake. Okay. If no other questions, then I'm going to go ahead and wrap up this session. I'll kind of move to the next thing I was going to talk about, which is more about TerraFlex. I will make some comments here, but I'm actually going to switch apps on my phone as well, because again, I don't want to kill you with PowerPoint, so stand by. I'll make a couple changes here. I'm going to close Field Maps. I'm going to close Trimble Mobile Manager. But one of the unique things about Mobile Manager is that it's very tenacious. So that if I wanted to open TerraFlex right now, I actually couldn't, because Trimble Mobile Manager still has a lock on my GPS receiver. I actually have to go in here to my apps. And I'll come down here to Trimble Mobile Manager. And I have to do a force stop. Now I should be able to open TerraFlex. And this is either daring or not smart of me, because I had field maps going correctly. So let's see now if I can get this going. And because some other things with Trimble that may take a couple minutes to sign in. So I'm going to move back over here and talk about a couple of things while that's signing in. So a couple of things that I want to mention, and then I will show you as I can on the unit, and then talk about some things on the website. If you're not familiar with TerraFlex, it is a web-based app similar to Field Maps. It's more focused on just data collection. It doesn't have the interactivity with your back-end GIS that Field Maps does. So yes, they're comparable. Some people would say, are they competitive? Yes and no. It really depends upon your workflow and what's on the back end as to which app is appropriate. We have customers using both of them. It just really depends on what your typical workflow is. So a couple of the newer things that have come out, laser rangefinder integration. If I can get this going, I can show you that, but I don't want to take too much of your time. But we do have support laser rangefinders, so I can do offsets. The idea is I can't get to an asset. There's a sign over in somebody's private property. I need to get a location on that sign. Or there's a manhole in the middle of the street, and I don't want to set up traffic control just to get that location on that manhole. I've got a water meter right up next to the building, and I don't get very good GPS location when I'm up against that building, so that I want to be able to offset my location. In the past, you may be familiar with the Geo 7X, where we had an integrated rangefinder. With the different setups we have now, we don't have one that runs TerraFlex with an integrated receiver. So we typically use, this is from Laser Technologies. This happens to be a True Pulse 360. There's several different models they have depending on accuracy level and things like that. Another change is support for the Trimble R12. The biggest typically that's a survey receiver. We're starting to see interest for mapping applications when we need high accuracy mapping, and tree canopy or buildings are an issue. The R12's claim to fame is the ability to work extremely well under tree canopy. And it does that because of the technology in that particular receiver. So the TerraFlex can take advantage of that. If you've heard of the R12i, the R12i is a receiver that can actually take, has basically a, wow, I just forgot the term. You can lean it over. So you can take an R12 and lean it over, and the sensors in there will give you an accurate point for where the tip of your pole is actually recorded. So you don't have to bubble it up to get it good and level. It automatically takes care of that with a 12i. Today, TerraFlex doesn't have the ability to use the tilt sensor in it, but it can take advantage of the canopy enhancements that are there. If you used TerraFlex a long time ago, you're familiar with Trimble nSphere. We've made a move now completely to Trimble Connect. So most all of our users have switched over to Connect. Another new thing I want to go ahead and show, because this is different within the past probably 2 weeks. The sign-in screen, I'm going to show it to you here on the web side, but this applies on the mobile side as well for sign-in. Now, I'm going to show it to you in Connect relative to TerraFlex, but this also affects the Trimble Mobile Manager that I showed you for field maps. So this new sign-in affects both places. So I'm going to sign in to my Connect account, but now I have this new sign-in screen. Notice now that we have the ability, and I can increase this, I'm not sure how well you all can see that. I have the ability to connect my Trimble identity to a Google account or to an Apple account. This makes it really nice so that I don't have to sign in multiple times. It's not so bad when you're sitting at a desk and can sign in with a full keyboard, but it's much different when you're trying to sign in, from a mobile device. It makes it much more difficult. So I'll go ahead and sign in here. And after this, it's pretty much like normal. So it pulls up in Connect, and then you can see your different projects. Still refreshing. Let's see here. Okay, well, we'll let that refresh, and I'll go ahead and show you this. So now I'm back on my mobile side. See if this will connect up real quick. I'll just do a quick example of how the laser rangefinder works. I'm going to my Bluetooth, making certain that it's trying, I don't know if you can see the pairing down there. Let me reduce my, you can see down here at the bottom of my screen that it's working on pairing with my TruePulse. All right, let's see. Let me go back here for a moment. Sorry to switch back and forth, but I don't have that many minutes. So I'm going to take another couple minutes, then we'll see what questions they might have. All right, let's do this. And hang on. Okay. There we go. So here in Connect, now that I'm logged in, the projects are like normal. If you're not familiar with TerraFlex, then we go in here and I can see all my data. And go back here. think I got the rangefinder going. I'm just trying to verify that. And it's going to pull up all your different features. And you can see them on the map. No real big changes here, except coordinate systems. So in the past, we were always working on WGS 84, but now finally we can set up what's called a map workspace in any coordinate system you want to. So for example, I've got several set up for, as an example, here we go. I was able to set up this workspace in a state plane coordinate system to match whatever I need to. Today, we only have 2 different workspace options. I can either be in lat long WGS 84, or it can be in US state plane NAT 83 2011. Trimble understands the desire to support some older NAT 83s. Currently, we don't have that. This is all just the current data, which is the 2011. All right, I'm going to go back now to my mobile device. Just so you can see that, nothing particularly new here. The laser rangefinder didn't connect, so I'm not going to waste time in trying to get that back up and running. Oh, looks like I may have lost my device too. There we go. Okay. So this is what TerraFlex looks like. I can see my location status. Now, right now, I'm just using my real-time corrections as SBAS. This is what you would typically expect with a receiver where you're chasing sub-meter accuracy. And then in my settings, this is where you can see the information about the laser rangefinder. It's important to note when you're using a laser rangefinder, you want to make certain you put the height in there. That way it keeps the elevation information correct. All right, I'm going to pause there. Got a couple minutes left. Any questions before I finish off and hand it off to the next person? All right, silent crowd. I'll give the next presenter opportunity to take over. I will be around tomorrow during the exhibitor time period. So if you have some casual questions want to ask, you're welcome to join in then. I'm just kind of operate that kind of an open house for us as a vendor. So just chime in then and we can talk about anything relative to GPS or other Trimble applications. Thank you all very much.
Thank you, York. We did have one question in the chat, and you have a minute or two if you'd like to address it. How many calculations do you need to do in the field to use a TruePulse 200x offset with an Arrow Gold receiver? And are there any manual calculations involved?
So I'm not super familiar with the Arrow Gold and how it functions. So I can't answer that question. I know on the Trimble side, we support a single shot offset, which I'm sure the Arrow Gold does as well. But also on the Trimble side, we support a 2-shot workflow. And I can certainly show that tomorrow. So if the person that asked that question wants to see how that works, I'll be ready to show that tomorrow during our exhibitor time. The 2-shot workflow is very nice for long distances or for areas where you're concerned about the magnetic or the metal environment affecting the compass on a laser. So the laser's weakest point is the compass, and it can throw things off accuracy-wise. So it can be very helpful to be able to support 2-shot offsets. But I'm not exactly certain how that works with the Arrow Gold and those capabilities.
Okay. Thank you so much.
Right.
And the exhibitor presentation that York is referring to is tomorrow afternoon at 1 p.m. That should automatically be showing on your schedule for tomorrow to join that session. So again, York, thank you so much. And if you stick with us in the session today and anybody has any more questions for him, please feel free to post those in the chat and maybe he'll have an opportunity to answer you. But now we're going to turn things over to our next presenter, Michael Anderson. Michael, are you ready?
Yep, I'm ready.
All right, I can. So let me, okay, so you should have the ability to share your screen if you have a presentation to share.
Okay.
So take it away.
Okay. Well, thanks for attending the session. And I'd really like to, hear any ideas anybody has, for how you could use what I'm about to show you if you have any. Okay, so I'll have the camera on now. I'm gonna turn it off while I'm doing presenting. I'm not used to doing the Zoom presentations, and there's so much going on here. It's confusing me a little bit. A little bit of background, just real brief. I'm in Pennsylvania. I worked for Penn State for 8 years. I've been working on my own for 20 now. I started developing GIS apps in '92 with ArcInfo 6. So any old AML programmers out there. Today I do mostly database and API development and build web apps with open source, various different libraries. And if you have any questions, please interrupt me because I won't be watching the chat window. So yeah, if you have any questions, please ask. And even now, yeah. Okay, so what I want to show is that you can, so what I'm demonstrating is you can do a full analysis in the browser. You don't really need desktop GIS to get clipping and buffering and calculating stuff. And I'm going to use a particular application as an example. This is a LESA application up here. See LESA, that stands for Land Evaluation and Site Assessment. So counties in Pennsylvania have farmland protection programs, and they'll get multiple applicants in a year, and they have to prioritize which ones to purchase an easement on. So, they did this with paper maps for a long time, and about 15 years ago, I developed an ArcMap toolbar that they use to do the assessment. But that's getting pretty old, and it's got problems with updating data and stuff, keeping stuff current. So that's always been a problem. So I'm proposing doing something web-based, and I've been talking about it for a couple of years. And this year, I decided to finally build something just to show it. So this isn't a full LESA assessment, but it shows that you can do everything. And I'll just I'll show you kind of a completed one, so what you're going to see at the end, so then you can see how I get there. So like this would be the parcel for a farmer who has applied to the program that they want their farm to be preserved. And they'd look at various criteria. Here, wait, let me show the layers. They look at various criteria to determine, to prioritize the farms. And they have there's a set, the LESA thing is a statewide standard. The land evaluation part's all based on soils, and it's uniform across the state. And then there's other criteria like clustering potential, are there other farms nearby, development potential, are there water lines, sewer lines, roads nearby? Yes, so they got to assess all those and then come up with a score for each parcel. So like I said, so this would be like an easement, a farm somebody wants preserved. And then so there's the soils that, like I said, I'm showing a completed one here. So there's the soils that are clipped out for it. Not sure. Yeah, so the way the soils work, just real briefly, so every soil in the county has a score, but with 100 being the best, and then everything else is relative to that. So to do the soil assessment, you clip the soils with the boundary and then do an area weighted average of the LESA score, right? It looks at water and sewer service areas to see if they're close. So you get some points if there's water areas, service areas nearby, some more if there's sewer, and then if there's both, you get even more. And then it looks at, turn these on off so you can see. You can see the road frontage right down here. So it looks at the road frontage and then gives various points based on how many feet of road frontage there are. And then this is like the score for this one, when it did the analysis, 84 was the soil score, and it got this many points for the road frontage and easement. And then there's some criteria that can't be done with the GIS, like scenic and historic qualities. So the user could type in whatever it should be. And if they know for some reason these are wrong, because sometimes there's just weird situations, they can adjust it here. All right, so now I'll run a real one. I'll just do it on the neighboring one here. Well, wait, let me first show you. So all the, I should have, let me back up a second here. So all the data, the data source for all this are just regular ArcGIS server map services. So it's this service right here. This is where it gets the roads from, gets the parcels from here. is somewhere. There's it's not sewer lines. There's a water service area, sewer service area. So it's pulling everything just from a regular map service, which, like, if this was implemented, would make the updates trivial, because they wouldn't have to try to send, you know, data to some office somewhere. They could just update the map service, and everything would be updated. So again, like, all the analysis from this is just pulling stuff from that map service. There's no other data source at all, and nothing else is going on the server. Everything is going on in the browser. So let me start. So the first step would be, you know, picking the parcel that the person, you know, that the person owns. And this is just giving me a warning that I'm going to clear out the data. So now, yeah, so this is the one somebody said they want to be preserved. You can change the name. That's the name from the parcel layer, but you can change that to whatever you want. And I should say, so it grabbed that parcel from the map service, but it's local now, and you can edit it. You know, eventually you'll be able to. I have other apps that I showed, like the editing, like cutting out holes and splitting and all that stuff. If anybody wants to see that, I can show that at the end. But you'll be able to, you know, do full editing. And again, this is just a demo to show people you can do it. So, because people were questioning whether you could do it. All right, so you can adjust your parcel as you need, and then you can come up and, you know, pick assess soil. So it hit that map service, grabbed all the soils that touched that polygon, and then when it made them local, it clipped off, you know, it's outside the parcel, and it did the area weighted averaging. So there that is. And then, so just did the roads, so it buffers it just a little bit to see what's adjacent, what's considered adjacent, then calculates the feet and assigns a score. And it just did the water and sewer service areas. It has two radius, so within 150 feet is one thing, and then within, I think it's 500 is another. So you can do like different, you know, buffers. And in this, I point out, so I showed you in here that these are actually, the water and sewer service areas are actually two different layers in that map service, but they're assessed together for this county. So I grab the features from both services and pull them into one, you know, locally. So that could also be used, or we're going to use it for one of the things that's always been not really a problem, but something that would be nice to handle is if you have a parcel on the county border. So this way, if you had a parcel on the border, you could grab the roads from your county and the roads from the county across the border, because, you know, they would also have a map service, and then merge them into one for the purposes of this assessment, you know, and then assess them all together. So that'd be a big advantage. I'm just looking at my notes here, see if I forgot anything. Oh, yeah, I think that's okay. So the county that I started working with this, he said he didn't really want a back end. He didn't want to set up, because I was initially thinking, you know, now you'd save, you know, you hit save this to a database, you know, kind of like a normal thing, but he didn't really want a back end. So I set it up. Normally I would save that to the database, like in JSON format, and then parse it out into database tables on the server. But since he didn't want that, I figured I would just slightly modify the JSON file, and then you could just save it locally. So if you hit save, it'll just save a JSON formatted file to your hard drive. And you can kind of think of this as like an MXD with the data. So it defines the layers and the symbology and the labels, but it has the data in it as well. So now let me go to that folder. You won't be able to see me grabbing the folder, but in here I'll load a different one. So I'm just grabbing that JSON file and dragging it onto the browser. So there's an assessment I did, you know, earlier in a different demo, and I'll bring the one back that I just did now. So you can save those files, you know, just locally. There's nothing going on the server at all. Boy, you can see I'm going way too fast here. Okay. Yeah, so another thing I wanted to show is I've been developing this. It's more like a pattern than real software. I mean, it's implemented in software, but so the pattern is you define a function that retrieves data, whatever data you need for your purpose, in this case, the LISA assessment. So that function will define which layers you want and which attributes you want from those layers. And those layers can be ArcGIS map services or OGC map services or like a custom API, anywhere. So you can pull stuff from any map service that exists. So you set that function up so it retrieves all your data, and then you just pass it shapes. So in this case, you pass it that polygon, and then it just returns to you all those layers with the attributes you defined, and then you can go on with your analysis. So it kind of abstracts the retrieving the data part, so you can just focus on the analysis. And so let me show you. So I read it. So what I just showed you this way, going one at a time, like this is what the toolbar they use now. That's what they're used to. So that's why I did it that way. But then I did it this other way just to show, how you could do it. So I'll do this parcel. Well, and that's a good one because that's a kind of a complicated one. It should work on a multi-part one. So we'll try it out here. And again, I could edit it, but so this button is just going to get all three of those at once. So there's one function that gets to all three of those layers, and I just pass it that complicated shape. And there it is. So it clipped all three. Yeah, they did the very same analysis. So it's really the same as doing the individual ones. It's just much faster and much easier. Like from a developer perspective, like I said, you work on getting the data, and then that you don't really have to touch that again. You just pass it shapes and it passes you back all the data. Yeah, boy, I went way too fast. So another advantage of the JSON file is, well, you can give it to somebody else. So you can send that file to somebody else and they can drag it on and they can see it. But you can also, because a big part of this is generating reports, which are pretty standardized. The state has a pretty standard format for the reports. And that's always one of the big issues. I mean, the counties handle that in many different ways. So with this JSON file, like I said, it has all the data from the assessment, everything, including the shapes and everything. So I'm setting up the report generator that you just send it that JSON file. You don't have to, it doesn't do anything on the back end. So it's not like you're sending it IDs or something and it's looking up data on the back end and then creating this PDF. You send it all the data, which is, I thought was kind of cool technically at first, but then in talking to the counties, they didn't really want to each one have to set up a report generator themselves, because that would be the hardest part of the system, most complicated part of the system. So this way you could just have one for the whole state, but the counties aren't really sharing data because the data is coming in from the outside. So it's not like any county could get to any other county's data, even though they're sharing the service. So like I said, at first I thought it was kind of technically cool, but but it actually, it's going to be actually useful. And I guess I'll show an example of a report. Just it's from a different application, but it's the same idea. So this is just going to create a PDF report. It's totally different information than what the LISA one would be, but it's the same tabular data and maps. It's same format. So it inserted multiple maps in there and looked up all kinds of data. And so I implemented it the same way as as I'm going to do for LISA. So I retrieve the data. In this case, I'm not sending all the data from the application, but I retrieve all the data from an API in one step and then send it to the report in a second step. So it's kind of implemented the same way. It's separate from the back end, really. Yeah, I get that. Yeah, I went way too fast. I guess I have more had a 15-minute presentation. So are there any questions, or anybody have any ideas of how you could use it? I'm trying to get back to my share here. There we go. Well, if there's no questions, yeah, that's pretty much it.
Okay, awesome. Michael, thank you so much.
Thanks.
Let's go ahead and kick it over to our next presenter, Meryl, if you're ready.
Hey.
Okay. You should have the ability to share your screen. If you don't, just let me know.
Okay, great. Just wanted to check in on my audio. Does that sound good to everyone?
Sounds good to me.
Okay, great. It's a little echoey on my side, but I can deal with that. Okay. Okay, just gonna turn the camera off while I'm presenting. Well, hi everyone. My name is Merrill Friedrich, and I am a GIS analyst at the West Virginia Division of Natural Resources. This is my first year at the DNR, so it's also my first year at the WVAGP conference, and I'm very excited to be here. So today I'm going to be talking a little bit about my work at the DNR that I've done on updates to our landscape integrity index map. So I'll start off by just describing what landscape integrity means, and then the methods used to develop the model and some example applications. Okay, so landscape integrity is considered a measure of a landscape's naturalness, or inversely its level of human modification. And this is also sometimes called the human footprint model. West Virginia, as we know, has a diversity of landscapes ranging from highly developed urban centers to roadless wilderness areas. So in creating this landscape integrity index, we can incorporate the many human impacts that go into making an area more or less modified and put those into a single metric. So just looking at these two images, we can intuitively recognize that the top photo of Charleston has more human modifications than this bottom photo of Laurel Fork Wilderness Area in the Monongahela National Forest. So what the Landscape Integrity Index allows us to do is to quantify values for these areas, as well as for the many values for areas for landscapes that fall somewhere between Charleston and Laurel Fork, where you may not be able to tell at a glance so much how modified an area is. Landscape integrity maps are created by combining the spatial distributions of various human activities and infrastructure, things such as roads or mines or croplands, etc., and combining those into one continuous surface. So we have an existing DNR landscape integrity model that was built in 2008, and it's shown here on the left. It has the high integrity areas indicated in blue and ranges down to the lower integrity areas that are in red. So this was developed in 2008, and hard to believe it was almost 15 years ago. So it's time for an update because we want to put in new data that shows 15 years worth of changes to the environment and improvements in data accuracy and some new analytical methods. So we can expect the new map to look broadly similar, but it'll have those updates incorporated. And as a note, if you're interested in other landscape integrity maps, there's also this NatureServe landscape condition map, and this one covers all of North America. So if you're looking for a product that's a broader scale, this is a good option. But for us, we are looking to revise the landscape integrity map at the state scale because this allows us to concentrate specifically on impacts to the West Virginia landscape that are evaluated by state natural resources professionals. And you can see there is a good deal of difference in different landscape integrity maps, depending on how you parameterize your model and what factors you include, et cetera. So any number of environmental factors can be considered in a model such as this, and factor selection can be tailored to a wide range of management and planning purposes. In our case, the DNR is largely concerned with better understanding human caused impacts on the environment in order to identify areas of potential conservation value. So we chose factors based on three broad categories using a combination of values from the literature and expert opinion. So we looked at introduction of foreign matter, contaminants, and pollution, things such as acid mine drainage shown in this image here. We also looked at extraction of natural resources, such as in this quarry near Germany Valley. Okay, hopefully you can all hear me. I was getting messages about being muted. Okay, I'm just gonna take that as a yes. Okay, great. Okay, so in the third general category of factor selection is disruption of landscape flows and processes, or landscape fragmentation and alteration is another way to think of that one. Okay, so we're including these 13 factors listed on this slide, although the model's still under development, so the specifics of these might change a bit. Our aim was to assemble a set of factors that cover the extent of mapped human land use in West Virginia, but don't overlap excessively. So for example, it would likely overrepresent the effect of houses in the model if we were to include, developed land cover and structures and impervious surface and housing density. So we tried to avoid too much overlap there. And then in order to reduce our bias and to streamline future updates to the model, we selected spatial data that's publicly available at least the state level or maybe even the national level. So most of our state level data comes from the DEP, Division of Environmental Protection. And then we've also got national data sources coming from a variety of sources such as EPA, DOT, Division of Energy, National Land Cover Database, the Wind Turbine Database, and more. You may notice that we just have the one aquatic factor included, and that's impaired waters, sometimes also called 303D streams. And that was intentional based on that we are also developing a stream integrity index, which will follow the same basic principles as this model, except that it's designed specifically to assess aquatic habitats. So we'll be more set up to address those factors in that analysis. Okay, so some human modifications are going to affect the landscape more than others, and we account for this in the model by giving them different weights. So like I said, it's still under development, so some of these things may change a little bit, but this graphic shows at this point how we're planning on accounting for differences in the intensity of impacts on the landscape. So for example, roads are ranked as having higher impacts where they occur because they fragment plant and animal habitat, they form a barrier to animal movements, and they may alter temperature or water flows in their vicinity and potentially be a pathway for introductions of contaminants or invasive species. And you can compare that to something like utility corridors, which was ranked as having lower impacts because while they do also fragment the landscape and somewhat disrupt natural processes, the effects are not as intense. So just to pull out the land cover variable independently for a second, this one we deal with a little differently. We're also internally weighting the different land cover classes based on a similar scale of low impact to high impact. But you may also be able to rank things as no impacts, things like forests and wetlands that aren't going to have those negative landscape impacts. Okay, so the second way that we're parameterizing factors in this model is by estimating how far their effects reach. So we assume that a feature's impact is going to be greatest at its precise location and then diminish as you move away from it. So for example, a wind farm may negatively affect landscape integrity through fragmentation of wildlife habitat, introduction of impervious surfaces, interference with bat and bird flight. And these effects are going to be strongest at the location of the turbine and then diminish as you move away. And the value that we've assigned to that is 1 kilometer. And then I mentioned before the ways in which roads may affect landscape integrity. But the magnitude of the effect is likely going to vary based on the size or the type of the road. So we allowed that to vary in the model as well by assigning different distance categories to different road types, such as highways or local roads or trails. So a road like the one pictured here, this is near Canadian Valley, it's going to have an effect on the landscape at a distance of 1 kilometer is what we estimated. Okay, so once you've got all those values, which is the most time-consuming part of this process, I think, then you can put them all in the model. So to demonstrate the model, I've zoomed in on one feature. These are oil and gas wells, and this is just a sample area close to Tiger Lake State Park. So the first step is to apply that fuzzy membership, and this is where you quantify those distance effects. So the effect is set to a value of 1 at the site of the impact, like the oil and gas well shown here, and then it diminishes to 0 after it reaches that maximum distance effect. So for this factor, we set that at 500 meters. And then to account for the assumption that landscape impacts are going to be greater, where the concentrations of that feature are the greatest, we also calculated a normalized kernel density value over 1 kilometer area. And then this fuzzy membership value and the kernel density value are summed and normalized again to form this final impact layer for this feature, which also has that symbology of like red at the areas of highest impact and scaling down to blue as the effect gets weaker. So you want to do this for each impact that you have. For this specific little sample area, we've got oil and gas wells, roads, impaired streams, and land cover. So we've got the roads here set to a 1 kilometer area of impact, and then the impaired streams are set to a 500 meter area of impact. And then the land cover doesn't have that distance variable, but it is weighted internally according to the different types of land cover. So in this one, you see the areas in red are hay and pasture, cultivated crops, and different levels of development. So once you create each of those independent layers and normalize them, you do a weighted sum. And this is where you integrate those weighting values that came from expert opinion and from the literature, so that you can make the features that are going to impact the landscape more, such as land cover or roads, you just give them more emphasis in the final model. So the final layer, like the one shown at the right here, you can view it like it's shown here as the continuous scale that shows like a gradual gradient from high to low impact, or you could also potentially classify it into categories that are meaningful to you, like high, medium, and low intensity of impacts. So on its own, the landscape integrity map paints a broad picture of the distribution of human activities, but most of its utility comes as an element in other maps or models or other decision-making processes. One of the main uses that we have for it at the DNR is to use it as a component in our land acquisition model. So this model shown here evaluates different potential land purchases based on the nearby availability or scarcity of hunting areas and the conservation value of the land in question. So you have your landscape component, which is highlighted here as the black box with the white text, and you combine that with ecological integrity, which is another similar model. Then those form your integrity component, which you would combine with the diversity component and important species component to develop your set of ecological factors that are considered when you're undertaking land acquisition decisions. A second way that we're using the landscape integrity model at the DNR is as a variable in other models predicting habitat distributions of sensitive species, like this one that shows the Allegheny wood rat distribution, habitat distribution. So wood rats, like this little guy pictured here, they prefer large contiguous forested areas, and they can be sensitive to different types of human activity. So they may select habitat that is away from human disturbances, such as roads or landfills, et cetera, et cetera. So it's important to consider those variables in the model, but sometimes you're using a modeling technique that will penalize you for the number of variables you include or for including correlated variables. So the Landscape Integrity Index can be very useful in that it distills multiple human impacts into one variable and can be readily integrated into a model, more readily integrated than its dozen or so component parts. So instead of adding many individual variables for human impacts, you can just add the one Landscape Integrity Index variable. Okay. So basically, the Landscape Integrity Index map, I think, is useful for any project where you'd like to quantify or visualize relative human impacts on the landscape. Some other examples, although these don't have any plans to be employed, but I think it could be useful in these cases. It could be employed as a variable in a model that is mapping sites for construction of wildlife corridors. Wildlife crossings are, I think there's federal funding coming down soon to build wildlife crossings over highways that will allow, wildlife to move through areas. So if you map out areas of high integrity that are split by a major roadway, that might be a nice area for a potential site to add one of those wildlife crossings. This model could also be useful in purchases or easements for mitigation companies, where you're thinking about your return on investment and balancing the cost of the purchase and the cost of the remediation with the likelihood of meeting your restoration obligations. It could also be used to promote tourism by highlighting the naturalness of a certain area, a town or a park or a management area. But if you have any other ideas of uses or ways that you use landscape integrity indexes in your own work, I'd be interested to hear about your experience so I could potentially work that into our model and make it more useful for everyone. So if you're interested in using this landscape integrity index map, it will be ready later this year. It's under development now, but when it's ready, it will be up on the WV GIS Technical Center data clearinghouse. And if you want the 2008 model, it's available up there now. Okay, so thanks everyone for your time. Thanks WVAGP for giving me this opportunity to deliver this presentation. Thanks to everyone at DNR who contributed to this project, and to Elizabeth Byers for walking me through and giving me insights on how she developed the 2008 model. There's plenty of time for questions if anyone has any questions. Otherwise, my contact info is listed here if you'd like to reach out about anything at another time. So thanks again.
Fantastic, Meryl. Thank you so much. Did anybody have any questions for Meryl? Right. Okay. Well, next up we have Stacey McDaniel, Sheldon LeMay, and Amanda Smarr presenting GIS work each of us has been doing throughout individual regions. Okay, so just whoever wants to share screen whenever you're ready, feel free.
Let's see. This is Sheldon. Can you see my screen?
Yes.
Okay, should say Region 1 GIS and has the conference background.
Yes.
Okay, good. Hi, I'm Sheldon LeMay from Region 1. We provide service to the Fayette Raleigh MPO along with Region 4, and also there's 6 counties: McDowell, Mercer, Monroe, Raleigh, Summers, and Wyoming County. We use Esri products such as Survey123 Field Maps, Tracker, ArcGIS Pro, and some other items. I'd say the majority of the things that we use would be Survey123 Field Maps and the dashboard. During the COVID-19 pandemic, the beginning of that, we worked with Region 4 and Region 7, and also the West Virginia Association of Regional Councils, the Chamber of Commerce, New River Gorge Regional Development Authority, and the West Virginia Development Office to create a couple of surveys to try and collect the data about the impact that COVID had on businesses. One of the surveys is here. It's basically a business impact. Sent that out and just asked questions, general information, your location, but also questions about, what county, because this was sent statewide, what county you're in, was your business impacted or do you expect it to be impacted, what types of impacts. There was about 18 questions ranging from how many full-time employees, and any kind of insurance you may have. Does your insurance cover wages? Just different things like that, trying to collect all that data. So when the time came, we would have it. And, for any federal funding that may come down, at least we would have the information and had a good start on that. From the survey, there was also a dashboard which would allow businesses, they could go in and put in information. This is one of the dashboards. This is, I think, was set up by Stacy, which sort of just give you an idea of how many responses we had throughout the state, and you can select it by the county. It shows you the information just as far as the raw numbers, but it does not give any detailed business information. That's only set up so the economic development and other regional councils and other entities like that could get that particular data, but it is just for public view. The other thing that Region 1 works on is, or currently working on, mapping dilapidated structures. There's, so far we mapped over 1,200 in McDowell County and Wyoming County. We're currently still working on Wyoming County. And basically what we did with that was to create a survey. And there were some 5 key elements that we look for when you're looking for dilapidated buildings. We went out, it was all done from the public right of way. You're looking at building frame structure, roof, chimney, gutters, windows, doors, siding, near paint, porch, entry, overhang, and decks, those features. For each one of those, there was a building element. You could determine if it was no visible problems, fair condition, or major. And basically the no visible problems would be if you couldn't see any because you were not able to get on the property and walk around the building. So it could have had some, but we just didn't see it. So we mark it that way. And eventually, once you put all that information in, you have an option. Here's the survey here. You go in, for example, no visible problems. This could have been minor, could have had major here, another major. Depending on what you chose, it would give you either poor, which means it was dilapidated, or you get a fair, or some cases, if it's all major, it's going to be, should be demolished. And these were the conditions here. There were a few extras that we didn't need to go through all these steps, because if it's just building rubble and debris, junk cars, there's nothing to evaluate, you just label it. So we just added a couple of extra ones in there. As far as the dashboard, that was made available both McDowell and Wyoming counties for their for the county commissioners to take a look at, and they can just get an idea of, okay, here's where all the problems may be, or the structures. If they want to do a plan or apply for grants or focus on an area, at least they'll know where to start, and they have some information has been collected. And we took photographs, of course, so they could get the information, see the condition of them. And that's just an example of one. Region 1 also uses Survey123 and dashboard to track and monitor sound registrations for a lot of the communities that we did serve. Basically, it's just to give us an idea of what's what will be expiring this month, next month, any that are inactive. You can select the TSD or the commission or town or whatever. And here it just shows we have a site that's available for our staff, so they could actually see the username if they need to log in and do the account or the other information, the DUNS number, and you can just get a little bit of information just if they need to know if their registration is still active. So that's another way that we are using Esri products. We also use it for our applications that we submit, and there's also one for funding. This basically just shows the name of the project, the amount, who the applicant was, and sort of gives us how many we had in. You can choose your time frame, or you can choose it by communities. If you want to break it down that way. We also do a funding, so we can see what's actually been funded for those projects and keep up with that. Tracking our mileage, and there may be, I'm sure other people are doing this too, but this is another use. There again, Survey123 in the dashboards has been very helpful for us. This would allow our financial people to see, especially doing billing, you can break it down and see how much has been, how many miles have been charged to different counties and then different jobs within that. And it also, we have it set up so it gives us cost, and that helps them out a lot. And I guess finally, there's other stuff we're working on, but this one is a business inventory survey that we done for Welch. And with that, we went out and mapped a lot of the businesses that were mainly in the downtown area, but some other ones. And here with the dashboard, it just shows it's broken out by industry, the name of the business. For example, here, that would provide information as far as if it has utilities, electric. A lot of this isn't populated, but it will be. But this was set up so if you know all of this information, the water service size, things of that nature, you can put all of that in. There's a photo that we did for each one. And eventually, what we'll end up doing, and we're currently working on it now, is getting this set up so it can be on their website. So an individual can click on it and see what properties are available, and also get the information as far as the services, the cost if it's for sale, and image of it, and also allow individuals to list their properties for sale on the website. And that's all I have. If you have any questions, you can email them to me, chat or whatever, but for now I'm going to believe Stacy's going to be next, so I'll turn it over to her.
Thanks, Sheldon. But I think Amanda, I think you were going to go next today, if that's okay.
Oh, okay.
Yep, that's absolutely fine.
Let's see, let me.
So while he's stopping his share and I'm getting ready to start mine, I'll introduce myself. So my name is Amanda. I'm with Region 4 Planning and Development Council. You should be able to see my screen now. Are you guys able to see that?
Yes.
Okay. All right, so again, I'm with Region 4 Planning and Development Council, and just like Sheldon and Stacy as well, we do a lot of similar things. But we also, within the regions, work on a variety of things that are, I guess you would say, outside the box. So we don't necessarily look at things, we do a lot of infrastructure projects, water, sewer, broadband, but that's not all that we work on. A lot of our GIS capabilities fall within those projects and much, much past that. So we'll go through some of those. And again, just like Sheldon, if there are any questions, you can feel free to ask it at any time. So we serve 5 counties: Fayette, Nicholas, Pocahontas, Webster, and Greenbrier counties. Those are the areas that we are in. We use Survey123 in a variety of different capacities. Just like Sheldon, we do the mileage report, expense report, but one of the things that we utilize it for also is signature of documents. We realized we were basically chasing our tails, going around trying to get people to sign certain documents, and it was much easier to be able to set up an application for them to sign it digitally and send that to us. So we also utilize it for that as well, and agenda presentations. So instead of sending out paper agendas, most of the agenda presentations that we do for our meetings or any presentation is done by ArcGIS story maps. So we'll go through a few of the projects that we've done. The first one that we'll look at is the Golly Bridge asset mapping project. We set up a simple survey in Survey123, and we sent an intern out into the town of Golly Bridge, and he collected all of the assets that the town had. You know, just like a lot of towns within West Virginia, some of our towns are extremely small and they're rural, and they don't have the capacity to even log a lot of their assets within their town. So they don't know if a natural disaster comes through and street signs get taken out. They don't know what signs may have been there. So that was the main purpose of this project. So a lot of things were mapped on this one. You had street signs, sidewalks, light poles, anything that would be considered an asset to the town. They looked at and they mapped along with pictures, so they could see the condition of the actual asset at that time. And that's going to help the town in a lot of different ways. Like I said, they'll be able to do future planning. They'll be able to know this is what we need to kind of update, or we need to plan for this, or they'll know that, hey, you know, this should be here. We need to make sure that we replace this in the event of a natural disaster. We also have mapped some abandoned and dilapidated buildings. Our main focus has been abandoned and dilapidated buildings, but as well as within the floodway. Even structures like a doghouse that's within the floodway can cause immense issues in a natural disaster. So we try to get those structures mapped and available to the community so they're aware and they can kind of start to look at some solutions that they may be able to provide. We're also working on a project currently for active businesses. The active businesses, one, we need to know what businesses are within the region for economic development reasons, but we need to know which ones are active. And that's not only going to help the region, it's going to help the entire state, because as we build that database, as we build that information, we can then provide that to the economic development agencies, and they can provide that out to anyone that's interested in the area. And we can also look at additional sites that may be available and look at future projects that way as well. So that information will become crucial and in future planning. When the COVID-19 pandemic hit, there were a lot of questions about who's being affected, how are they being affected, and what can we do? One of the things that we looked at was how the PSDs, or the public service districts, were being affected financially by the COVID pandemic. So we put together a survey and we sent that out to the public service districts to really kind of figure out how are you guys doing financially? What do you need? And the state received that information and used that information to decide their next solutions. So we did use that to kind of gauge how the pandemic was hitting the public service districts. Now, Sheldon mentioned that we did a COVID-19 hub site. And so this was to gauge the impact on businesses. There was a lot of information that needed to be gathered, and there was a lot of information that needed to be provided. So we wanted to be able to provide some information to the public, you know, amended business hours and things like that. So we put together this hub site, and this hub site, although we have surveys within it, this hub site we created it, had a little bit more back-end coding than most of the other projects that we talked about. But we put this site together so that they were able to see what we were doing, what we were trying to gather, and a site that was functional for them to be able to go through, utilize it, and then provide available data back to us. So we had the business amended hours survey on here, as well as the business impact survey. And we also kind of explained to them what we're doing with this data. We didn't just ask for it to be asking for it, that there was a reason for it. And we also showed them a map of some of that data as it was coming in. Obviously, we made sure that the data that we showed, this one is just going to show the business amended hours. We didn't show any sensitive information to the public. And they also, so on the back end, and Stacy will probably talk about some of this, and Sheldon mentioned it, on the back end, we also had a variety of dashboards and information that we were able to filter through to really make some informed decisions on next steps of this. But so this was the COVID-19 hub site that we worked with all of the regional councils, as well as the state of West Virginia. And finally, broadband is a huge issue within not only our state, but many others. And we do a lot of projects that deal with broadband. And there are a lot of maps out there that say that there are certain broadband speeds in areas that we know to be untrue. So the only way to combat that is to combat that with accurate information, accurate data. So we develop a lot of surveys for certain areas, send the surveys out, take the survey, and then provide accurate data back to us so we know exactly what speeds are there, what providers are there, and really have a strong foot to stand on and understand where certain projects may need to occur and where certain areas may need to develop a little bit more. And we do that in Survey123 Connect typically, because we need a little bit more of that functionality to be able to set up some of those questions. And that's all that I had prepared. If there are any questions, please don't hesitate to let me know. I will stop my share and I'll turn it over to Stacy.
Okay, let's see. Let me get this up here. Okay. So, all right. Can everybody see my screen?
Yes.
Okay, thanks. So I'm doing, Region 7 is doing similar things as to what Sheldon and Amanda said with all of their Survey123 and some of the dashboards, which I'll get to in a little bit. And Region 7, we have 7 counties. We cover kind of North Central and Barber, Braxton, Gilmer, Lewis, Randolph, Tucker, and Upshur. And we've been working with several of our municipalities within that boundary. We've been focused on implementing our GIS services in part of our project planning and development at Region 7. I've been there for 3 years and I've been trying to expand the GIS within Region 7. In 2019, we actually initiated an enterprise agreement with Esri as part of this initiative, and that's allowed us to expand available access to the software and also offer discounted rates on certain products for those entities that want to take advantage of expanding their GIS. And main thing that we've been doing personally in the last 3 years is working with the utilities to do asset management. We've also done some dilapidated structures inventory with some Flexi grants that we got that ended last year. And then also, like Region 4 and Region 1, we are actually also doing some project tracking and reporting within Region 7 offices. But what I wanted to spend most of my time today is the utility management. The technology and services that GIS allows with this agreement has given us the ability to help asset organizations manage their assets more efficiently. A lot of the information we found is basically in what they call institutional knowledge, which is where there are a couple of individuals that know where all these assets are located. They may have old maps that are out of date, and a lot of these people are starting to retire or change jobs. and that knowledge goes with them. So what we've been trying to do is to take the software applications and through the website and mobile applications, taking this information, giving it in a format that's easy to understand and access, and also update. Plus, it allows your entire organization to be accessing the same data set, and it's as up to date as it can be. So what we've done is we started with the Esri solutions for water and sewer. I don't have a utility background, so I've learned quite a bit about what kind of assets there are. And we worked with each individual organization to customize what they want to collect, including the feature classes, the attributes, and the domains. And then we've created and built a geodatabase schema for each of those. Mainly, we've been doing water and sewer. And then we also did a streetlight inventory for Jane Lou. And I'll show you some of that data here in just a minute. So basically what we're doing is we're taking that, we're using Trimble positions add-in to actually create data dictionary files. And we're using Trimble Geo7X GPS handheld unit to actually collect the data. It's a little more accurate than some of the mobile applications right now, unless you have an external receiver, which we don't for now. And then we've been using Desktop Pro, ArcGIS Online, like I mentioned, positions. We've actually been doing TerraSync for the information, and then TerraFlex and Connect. We're working with that, like York presented earlier in the session, with the city of Buchanan for how they're managing their data collection right now. And again, the handheld GPS that we're using. So here, I wanted to show some of, get to the home here. So here's some of the data that we've actually collected with the utilities for the different projects. We started with the city of Parsons. This is kind of their water system that we completed. And you can see it, we've got mainly meters, water, all the above ground features. The water line that's shown here was actually digitized from record drawings. And you can see we've got a set of attributes for each one of those, and then photos. So, and we're currently working with the town of Beverly to actually do their water system. We're about 90% finished with it. They had similar information. So we have all the attributes and photos of the valves, but for their meters, they also wanted to include a location address and account information. So we incorporated that into theirs. And then here's a quick look at the sewer that we did for Century Volga, manhole information. And then here's just the manholes that City of Buchanan. As I said, they've been doing their own data collection. So Region 7's participating in kind of helping with their geodatabase management, data management, that sort of thing. And they're using the TerraFlex Connect combination to collect their data. And then here is the Jane Lou. They wanted to inventory all of their streetlights and poles within their town limits so they could have some more information. So this is a pole. You've got a pole number, type, and then a few photos. And then also the streetlight, we have it associated, so it's connected to that particular pole. So, and we've got upcoming projects with the Weston Sanitary Board in Lewis County. We're coordinating with City of Philippi to do their water system, and also the City of Thomas to do their water system. So this is growing, which is great for us. All right, so now I wanted to go over some of the dashboards. I mentioned the dilapidated structures flexi grants. We had two that we actually were part of. The one in Braxton County Region 7 was the applicant, but we also assisted the city of Elkins with theirs. And I'll just show you quickly kind of the dashboard that we have for that we put together for the data that we collected for that. We did Burnsville, Flatwoods, Gasaway, and Sutton. And as you can see, if we just filter in these, we use a similar background for what Sheldon showed earlier for the structures and the condition evaluations. That came from the West Virginia Bad Buildings evaluation form. And we put that into a Survey123 Smart form and use that to collect the data and the photos for that. And the city of Elkins, we helped them. We provided the survey. They actually did their own data collection. And they've since hired an in-house GIS technician. And this is their public-facing dashboard that they've created with that information. And they've also added kind of a status for their updated within their city. Okay, so here's, Sheldon showed this one. I'll just bring it up real quick. This is the business impact dashboard that we coordinated and put together. As you can see, we got almost over 600 entries, and you can actually filter by each county, the different businesses, the different questions, just a quick glance at the data that was available. And they both mentioned the admitted hours. I don't know if we saw the dashboard yet, so I'll just bring it up really quick. We got over 300, almost 300 surveys in that. Again, you can also filter that by the different companies. Find out the hours for that. And then if you click on this and the actual, you can get some more information about what type of business is, where it's located, and some of the contact information, as well as the specific hours. And this is public as well. Can access it through that hub page that Amanda showed. And then as far as kind of another dashboard that we're doing in-house, we're also using this to manage some of our projects, the projects that we administer. We've published this on our website for the commissioners and all the public access. This is showing the current number of projects and the total cost of what we're managing at Region 7. This is actually all of our non-GIS projects right now. We're still working on trying to figure out the best format to put our GIS projects in. But if you click on each one of these, kind of see the project area that we've gotten, projected cost, and a current status. And let's see if I can find one. Yeah, so there's the Century Volga sewer project. So you can see we actually have the exact outline, and this one's almost finished. And we're also using surveys like Amanda and Sheldon mentioned. We're doing more of our data collection with the GPS because of the utilities. They want some more accurate information than what we can with the equipment you have for the mobile devices. But what we are using it for in-house is our travel log, just like Sheldon showed. They're managing their company vehicle. And we're doing the same thing. We use a Survey123, and this is a dashboard. We actually mostly have ours broken down by projects. You can filter it by county, but mostly it's by project cost. But then I also wanted to highlight, we've added a component where we can actually, they wanted something they could print instead of just a dashboard to look at. So using the reporting capabilities in ArcGIS Pro, I put together a report from this feature service from the survey, and we can update that with whatever data, whatever filters we need to, and exports. We usually do it monthly, export monthly reports broken down by each project and the total cost for our billing and our information. And we're hoping to expand some of that within some more projects. As I mentioned, we've got several upcoming water and sewer projects, but we're also hoping to expand more of the internal use, like with the survey and the dashboards that we're using. And with that, I think that's pretty much all I have today. So anyone has any questions, I've put all of our contact information on. We've been doing a lot of collaboration over the last year, trying to kind of expand the GIS within all of our regions. So, all right. And then I'll stop sharing. And if anybody has any questions for myself or Amanda or Sheldon, I think we have a few more minutes before our time is up for that. Okay, well, if you guys think of anything later or want to contact us or have questions, feel free and just let us know. So thanks for your time today.
Thank you. Fantastic. Okay, so up next we have Erika Klose. Erika, are you ready?
I am. All right. Do you see my slides?
Yes.
Okay, fantastic. Well, I'm super excited to be here with you all today. As I sit and just listen to all of these projects, all I hear are opportunities that are available for West Virginia students if they were to go out and become GIS professionals. And so it's just incredibly encouraging to me, and I just look forward to what the future holds. And I hope that the changes that we are doing in K-12 will make a difference with the number of GIS professionals that that end up in the workforce in the coming years. So I am Erika Klose. I work at the West Virginia Department of Education. I coordinate STEM and computer science and GIS. And I have given updates before. Clearly it's been a while, but I'm excited to be able to share a lot of things that have happened in the last few years. And even some things that have happened in the last year, sort of in spite of the year that was 2020. So just to make you all aware, we do have a fair number of initiatives related to GIS that are occurring at the West Virginia Department of Education. Our primary role here is to create professional development opportunities for teachers and supports for teachers to allow them to bring GIS to their students. So essentially what that means is that we spend a lot of time explaining what GIS is, the importance of GIS, why it's important as a potential career path for students, and then how teachers can go about bringing GIS into their classroom teaching. So in order to make that happen, we have a number of initiatives that we have started and kind of carried through. A number of our initiatives really did get put on hold due to COVID. Our ability to clearly meet with teachers and to ask teachers and counties to do anything new was seriously hampered this year, as obviously our teachers were really concerned with some other things. So a number of our projects did get put on hold, which is sad, but it's exciting because now they're starting up again. So I'm really excited about that. But sort of in spite of all that, and in spite of the year that 2020 was, and the early part of 2021, a lot happened. So even, for example, even though, last year our teachers were exhausted at the end of that short little bit of 20 that we were all remote and online, last summer we did continue to have a fair amount of GIS training for teachers. So we have a number of opportunities for teachers to receive training in GIS, whether that is me going out to a county and doing professional development with teachers, or whether it is teachers taking courses online. All of those opportunities are still available, and all of those opportunities are increasing. So we're always sort of creating more and more opportunities for teachers to engage with GIS and to just learn what it is and how it can be used in their classrooms. We are still continually adding to an online GIS sort of atlas for teachers, which is for students, which has essentially become an online organizational account that we use to store data layers that we believe could be of interest to students and teachers for working within their classrooms. We're still working on developing some West Virginia specific GIS lessons. This is one of the activities that I say sort of got COVIDed, but it's restarting again this summer. So I'm really excited. We had a lot of moving pieces with that, a lot of partners that we worked with, and it caused us to need to do a pause, but we're back on track for that. Even last year and this year, we had participation in Esri's story map contest for West Virginia, and we were able to send 5 middle school and 5 high school projects onto Esri to be in their national story map competition. We have a single statewide organizational account for all teachers and students that are in public schools within the state. And we have more and more teachers and students that are logging in and accessing that. So it's really exciting for me to go in and just see how many more members there are in our organizational account, because it's always growing. One big project that we've been working on is creating a set of standards, so expectations for 4 high school courses in GIS. Those are essentially done. So we're moving on next to the next step with that. We have added a whole new online course for educators in GIS. So now educators have 2 options when they're looking to do an online course that they can get graduate credit for through the Department of Ed in GIS. And we're continuing to work on developing a high school certificate in GIS, which is where those 4 courses go. So, you know, one of the things that is really unique about what we're able to do here in West Virginia is that we are able to have this statewide organizational account, and it's for any student that's within the public schools. So all students and teachers in our West Virginia public schools have access to an @K12 or @stu.k12.wv.us email address. And if they have that, then we're able to allow them access to this organizational account. And it has really become one of the greatest benefits that I think that we have for teachers, because there are very few barriers for teachers or students to needing access to GIS. They can just log in. The first time they log in, automatically creates their account within the org. And then their account for the org is obviously maintained on our side with their email address. So that has continued to be something that allows us to reach a lot of teachers who normally would not be able to have access, because setting up their organizational account could be a little bit of a burden. I mentioned that we had our story map contest. The story map contest is run by Esri. We partner with a number of institutions, but primarily we partner with the Education Alliance, because the Education Alliance actually receives money from Esri. At the Department of Ed, we're not allowed to give awards, monetary awards to students. So the Education Alliance actually gives our students awards for winning, being in the top 10 story maps in the state, 5 at the middle school and 5 at the high school. And so they're a terrific partner with that. And the story map contest essentially just asks students to use the story map tools within Esri to tell a story of local importance to them. And we have some teachers that now use this as part of their instruction every single year. We're adding teachers every year. The quality of story maps is getting better every year. And I really have been encouraged to see that. The contest generally closes in March. This year, we actually extended it a little bit so that our teachers and students that had just gotten back into school still had a little bit of an opportunity to work collaboratively on some of these projects. One thing that we always encourage, and I always think of when I get to talk to you all that are within the GIS community, is, you know GIS, you know that, you know what it is. And many of you, I think, have children. So if you ever want to just reach out to your children's teachers and let them know about this contest, that could be incredibly helpful. The way communication works here, we send information out to superintendents send it on to their county staff send it on to teachers. And there are always a few places where that line of communication can break down. So unless the teacher is on one of our listservs here at the department, we may not be able to really reach them as quickly as we want to. So if you know you have this contest exists and you have a student in grades 4 through 8, that's what Esri calls middle school, or in 9 through 12, please, reach out to their teachers or reach out to me and just say, hey, Erika, can you send, this teacher information about this contest? I would love to do that. And especially if you're willing to maybe just hop into that classroom, whether in person or virtually, and just sort of say, this is what a story map is, this is what GIS is, it might really give that teacher a boost in terms of implementing GIS into the classroom. I put a couple of links to some of this year's story maps on this slide. There's little short links to them, and then there's QR codes if you want to scan those and look at the story maps. As Esri has changed and gone to the new sort of story map templates, I have found that a lot of our story maps have actually gotten to be a little bit less complicated. They tend to be better formatted. They tend to have a little bit less analysis in them. And that's certainly something that I've been working to support, so that students are not just literally placing points on the map, but doing some sort of analysis related to those points. So if you take a look at them, you see sort of where we are. And I'm sure that those of you that have any familiarity with story maps will see kind of what we need to do to move forward with those story maps. I will tell you, just hop back for a second. If you take a look at any, if you just Google the Esri middle school or high school story map contest, you'll land on the hub page that has all of the results. And when you look at the results of the actual winners, so Esri chooses national winners each year, it's absolutely fascinating what some students are able to do. And these are all student completed projects. And a lot of times what happens is that these, the winners are not necessarily students that are with teachers that have tremendous GIS knowledge. They often tend to be just incredibly motivated young people. So I certainly would love to be able to celebrate those students. And I'm firmly believing that we have those students here in West Virginia. We celebrate Geography Awareness Week and GIS Day. We celebrated it last year. It was a little bit of a challenge, but we did celebrate it. And we had a number of opportunities for students and teachers to engage with GIS, whether it was just understanding how to put one dot on a map, or actually using some different resources in their teaching. Teachers did a lot of different things, and I'm looking forward to this year, knowing and firmly believing that in November we will all be in classrooms again, and that all of our students will be a little bit easier to reach in terms of celebrating Geography Awareness Week and GIS Day. The governor always now does a proclamation for Geography Awareness Week. And I'm very thankful for that, because it certainly gives us just another little hook to say to the education community that, you know, this is important. I mentioned that we're creating that West Virginia Atlas. What we're essentially doing is just compiling data layers, and we've been doing a lot of work with students at Mount West Community and Technical College that have actually been working with us on some specific data layers that we had some educators request, ones that required data that required a good deal of sort of massaging to be able to get to a point of being useful for K-12 students. So we are currently getting the last few sort of initial data sets that we were looking at and getting them into the Atlas and getting them all essentially under the same account and login so that they can be searched by owner. We have actually two organizational accounts here. We have one that is our legacy organizational account, which is this one, the WVDE.maps, that we've had forever since organizational accounts first came out. And then we have the org that our students actually have their own personal accounts in, which is a different account, different organizational account. So we continue to build this Atlas. So we do have, like I said, 2 GIS courses available for teachers. We have a professional development platform here at the Department of Education where teachers can earn graduate credit. They can earn essentially a certificate from us that allows them to apply that towards a salary bump that teachers can get by taking courses, or they can actually pay to get actual graduate credit through one of our colleges or universities if they're interested in doing that. But we have a 3-credit course that we've had for a really long time that teachers can take that actually has them prepare to teach a course that we have within our computer science standards. That's called Computer Science Introduction to GIS. And so educators can take that course and figure out how they would teach that course to students. We have some educators that take it for that purpose and some educators that just happen to take it. Then I was asked to create a course a 1-credit course that could be stacked with some other courses to get an educator to 3 credits if that's what they needed for a certificate renewal. But it was determined that even though this course is really not tremendously huge, they still decided that because the learning was so huge within it, that teachers could get 2 credits for it. So we have a course on GIS in the classroom, which essentially has educators do some different Esri training, basic Esri training, and then explore some of the resources that exist to be used in the classroom, and then to plan a project in GIS. Whether or not they implement it is sort of beyond the scope of the course, but they do plan a project. And that is a big push within GIS in the classroom, is to going beyond sort of a canned packaged resource and moving into doing actual classroom projects. One of the things that we are still working on, a project that really did slow with COVID, was creating a high school GIS certificate. We do have those 4 courses developed and are now determining the process of getting those standards for those courses approved, and then creating documentation to support educators in teaching that course, those courses. And our hope and our plan is that if we could get students to actually take these 4 courses in a row, we would be able to then confer upon them a GIS certificate saying that we know that they know these skills and they are able to do these things within GIS. So additionally, we are also sort of creating parallel professional development opportunities for teachers, and also partnering with some other institutions like the Geotech Institute in Kentucky to provide professional development for our educators. Here at the Department of Ed, we do use Esri GIS sometimes. Not all of our maps are done, not at all are any of our maps done with ArcGIS, although occasionally we do. So the way things are going right now, if we have to put something on a map that is pretty complicated or data intense, it tends to land with me, and it gets built and then published using Esri products. We do have a few other mapping capabilities here at the department that are tied to software that we use for student information and things like that. That sort of famous map that was color coded and determined whether students were in person or remote, that that was done with something else. It wasn't us. It was very much a graphical map. But we are using GIS here at the department for some things administratively. One of the projects that we used was to create just this little application for parents and families that needed to access the Kids Connect Wi-Fi hotspots to show where they were, because they were in at our schools and our libraries and our higher ed institutions, at our National Guard armories, and then in our state parks. And just shout out to Kevin Kuhn at the Geotech Center, who helped me to deal with some of these data when we were first putting this together last fall. This turned into a much bigger project than it should have been, but we knew that our governor had requested that we have 1,000 points of connection for our students, and it took a little bit to get those out there, but they're out there. They're still out there. You may see the signs as you drive past schools and libraries designating them as a Kids Connect site. And it was encouraging to know that these actually were used by students and families when they needed them in the last year. So GIS is something that it's important. It's important to us here at the department. We're ever looking for opportunities to support GIS in education with students, to support our educators that are responsible for teaching geography to our students, and then to support our educators that working to provide information about just careers in GIS and those opportunities that exist out there. So if anybody has any questions or comments, obviously I would love to answer them now or to hear them now. But at the same time, my email is there on the slide. It's just eklose@k12.wv.us. And I always love hearing from the GIS community. And if you have any ideas or suggestions, or you'd like to be connected with a school in your community to act as a geo mentor, or perhaps provide some support, please don't hesitate to ask. Or if you're looking for resources that you would like to share with your own, with teachers in your community, perhaps your own children's teachers, I would love to help in that way and to be supportive. And just thank you to the community. Thank you for all the work that you do and all the support that you do provide. All right, and I'm available for any questions.
Hi, Erika.
Hey, Kevin.
Fantastic stuff, as always.
It's good stuff. I'm really glad we're moving past the last year.
Yeah, you and all the teachers.
And all the parents that had their children.
All the parents that had to have their children at home. Do you have a timeline for the certification for the high school GIS stuff? And is GIS-CI buying in?
I think that people are buying in. I think that we certainly, I mean, admittedly, we lost momentum because of COVID. We just had to put a number of initiatives here at the department just to the side while we've dealt with everything else. But my hope is that we can spend the next year creating all of the resources and perhaps the professional development for educators to use to teach these courses. So perhaps in a year or so, we could look at sort of launching this course. We're still trying to figure out, we have some policy issues about where standards like this actually live in terms of what policy and where they would go and how we are allowed to provide resources, because at the department, we're not allowed to say, use this exact curriculum. And where we've written courses for curriculum that doesn't exist, we're sort of in the process of figuring that out now. But we're certainly back to progressing, which is really exciting. And my thinking is that when we really start creating the resources that we can share, we can sort of share something that we call a toolkit for these courses. When we get to the point of toolkit construction, my feeling is that I might really try to reach out to the community just for some ideas related to, sort of profiles of projects within the state to use as examples for some of our educators. So I know those of you that know about the certificate have been sort of holding on for a few years now, but hopefully just another year or so. That's my goal.
It's fantastic. It's really, I think it's outstanding to get the lead on that. So
I hope we're still in the lead. There's another, Tennessee is doing some really good work. I'm not positive we're still in the lead anymore, but I'm working hard on staying in the lead with that, and actually have some great collaboration with folks in Tennessee. So the work's going to get done, and I'm ready for it to do so.
Hey, Erika?
Yeah.
It's Frank. How's it going?
Hey, Frank.
Pardon if my dog goes crazy. Apparently FedEx is invading the house. But I have a question. What can we in the community do to get a better acceptance of the utility of that certificate? Because it feels like something the association itself could do amongst ourselves to say, yeah, this thing is good and it's valid. It indicates a degree of competency that you can rely upon, instead of looking at an outside agency like GIS side to make that determination, since they seem a little hesitant to be doing that at that level.
Yeah, they really are hesitant to be doing that at that level. I will tell you, there was talk about having a student certification exam, and that all of that talk seems to have silenced an exam like a lot of the other exams that our students are able to take in other softwares. It seemed like Esri was having that conversation, which would have been really helpful. but that seems to have passed. So we're certainly just back to this. So I think that what I would ask is that, you know, when I say I think we have these standards done and these are the skills and that students should be leaving with, these are the activities that students will have completed before they get the certificate. You know, I think that when we actually sort of develop that certificate, the plan is right now that it is sort of stamped by the GIS, the State GIS Policy Council, and the, you know, State Office of GIS Coordination. But I think it would be incredibly helpful if when we create that actual certificate, you know, if we can say that, you know, that the association places their sort of stamp of approval on this, I think that would be incredibly helpful. I would love it at some point if I could also have, you know, even the folks that do the GISP, even just take a look at it. And I've have conversations with them, so that's not beyond the realm of possibility. But I think that any sort of backing that can come from the community will be amazing. Also, when we have these sets of standards that are that become essentially Board of Ed policy, they have to be reviewed by stakeholders. Because this is not a specific policy like math standards or science standards or something like that. They don't have to go out on public comment, but they will have to be reviewed. And in the front matter of those standards, we do list stakeholders. So my hope is that I would be able to share this with the community and anybody that wanted to review them and give me feedback and comments, that they would do so.
Great, thanks.
You're welcome.
So Erika, thanks a lot for coming, presenting, and keeping us informed of all the happenings of what's going on in Department of Ed and with the schools. So good stuff.
All right. If I can answer any other questions, please feel free to email me. I'll be here.
Hey, thanks. So I'm up next. My name's Jackie Strager and I'm from WVU. Let me just get my screen set up and go from there. So you should all be seeing my slide screen. Let me know if that's not working for you. Also, let me know if I'm not, if you're not able to hear me, but I'm going to be talking about Survey123, as some other folks have talked about. And I'm going to be talking about it in terms of engaging students and communities and the public. So my role, I work at a place called the Natural Resource Analysis Center here at WVU. This is within the Davis College at WVU. And we're a research and teaching facility in the Davis College that deals primarily with spatial data and spatial technology. So GIS, remote sensing, drones, and so forth. We do a fair amount of teaching with both undergraduate and graduate courses in applied GIS, mostly in the natural resource-based fields in our college. So that would be wildlife and fisheries, landscape architecture, energy-related fields, and so forth. And we also provide GIS support for WVU Extension. And this is primarily in the areas of economic development, tourism, and outdoor recreation development. And so with those two areas, undergraduate, graduate teaching, and GIS support for extension, I've found a couple different ways that Survey123 is useful in engaging those different audiences. And so that's what I'm going to be talking about. My uses of Survey123 are pretty simplistic compared to some of the others that you've seen, but hopefully you're able to gain some ideas from my experience as well. So Survey123 for ArcGIS, if you're not familiar with it, or if you weren't on for the earlier presentations, basically Survey123 is a data collection tool. We use it here at NRAC for both teaching purposes, just to demonstrate the capabilities, and work with community. And it is similar to SurveyMonkey or Qualtrics, other survey applications that you may have used if you haven't used it yourself. It comes as part of the ESRI or Esri ArcGIS Online license. It does come even at the business license level, and you can use it to support all sorts of different question types, the standard question types that you might see on different types of surveys, including multiple choice, putting things in rank order, just entering free text, entering dates, and so forth. And there's also the ability to support simple branching and logic. So if you ask a question and you want to go down a certain track, depending on the answer to that question, you can do that with Survey123. And it will be integrated with the Field Maps app from Esri as well. So Survey123 Forms, you can create a form and it can have any number of questions, but you can include one question per survey that has a map response. So you can collect the map response as a point feature or as a line feature or as an area feature or a polygon feature. And this is really handy because then your survey responses get stored in a database that is stored in your ArcGIS Online account. And you can then use those survey responses as a feature data set in a web map app, or even a dashboard, as you've seen with some of the other speakers and presenters. And presenting the information, presenting the survey in this way is really useful for a non-GIS audience. You can set up your survey so that you don't have to have an account to log into the survey. You don't have to have, excuse me, any GIS knowledge to answer the survey or to use the survey to essentially collect GIS data. And so it can be really useful that way. I have a couple of different examples where I've used surveys with GIS, and some of these examples are with my GIS students. These are in undergraduate classes. I've used it in both remote learning environment, which has been most of the last year, and I've also used it in in-person classroom teaching as well. And I've also used it in community data collection, where you're collecting data from either the general public or a specific audience to present those data sets to the general public. So just a couple of examples of how I've done this. So engaging online students, as everybody is obviously aware, as we're sitting in our online conference, in spring 2020, everything changed as far as college instruction. Within a 2-week period or so, we went from teaching in person to being informed that our classes were going to be converted over to online instruction by the end of March last year. And so we were really encouraged as instructors by WVU to find different ways of keeping our students engaged in the class and interested and able to communicate with one another and interact with one another, even though a lot of the students went home and were going to be learning pretty much remotely for the rest of the academic year. And so we did employ Zoom meetings. However, this wasn't that great for my class. Zoom meetings, we've all had our share of them. This is just a screen capture from one of my family Zoom meetings, but they present their own problems, and they presented problems, especially in an asynchronous teaching environment, which is what my classes were moved to. Asynchronous teaching basically means that your students are not all logging into the class materials at the same time. So you can't really hold Zoom meetings because there's no set class meeting time. We also moved to having some of our student interaction through discussion boards. So this basically is where the instructor posts a question and then students answer. This is okay, but this was used a little too much. And so I landed on using ArcGIS Online and Survey123 for my classes. And so the steps in using Survey123 are, first, you create the survey itself. I wanted to create a survey for my online students. I wanted to keep it very simple. So what I did was created a 4-question survey. Basically, I asked the student name so that I could grade the survey. I asked where their hometown was. I identified their hometown location using a map question in the survey. And then I asked them their major, and I asked them to just type in something interesting about their hometown that other students might be interested to know. Once the data were collected in Survey123, it gets stored in ArcGIS Online. And because I asked a map-based question, it becomes a feature layer. When I have a feature layer of my point locations of my student hometowns, I'm then able to set that up as a layer in a web map in ArcGIS Online. You save the web map and then create a web map application to be able to view the data. And then I provided that the content to my class. We have a content management system here at WVU called eCampus. I assigned the survey to the students by providing them with the URL for the survey. So basically you just take the website address for the survey and give that to the students. And then I also provided them with the URL or the website address for the mapping application that I created. So as more and more students responded to the survey, students would be able to open up the map and look at those student responses of their fellow classmates. And they would be able to see who had responded to the survey, where they were from, and learn a little bit about the people that they were in class with, even though we weren't able to meet in person or talk to each other in person. So overall, I feel it worked pretty well, even though this was a super simple application of Survey123. The main point of this was to get interaction going between the students rather than collecting data. The data that I collected wasn't really of anything that I didn't know already, but by providing it to the students in this way, I thought it was just a simple way to get them interacting with each other and using the technology at the same time. So I had a pretty good response rate. It was better than some of my other assignments. This was a low stakes assignment. It was only worth a couple of points for participation, kind of used as an attendance check more than anything. I did have 67 students that responded. And by asking them their major, what major they're in school, I'm able to map that major on the map. So the different dots on the map are locations of student hometowns, and the colors of the dots are just showing the students' majors. So the red dots on the map are students that are in the Wildlife and Fisheries program, the blue dots are in landscape architecture, and so on. I had students from 12 different states and one country. I had a student from South Korea. She's not shown on the map here, but she did put her dot on South Korea. And I feel that students were able to learn more about their classmates. If they did click on the dots on the map, they were able to see a pop-up that showed them whatever the student had thought was the most interesting thing about their hometown. So one of the first students that answered the survey was named Jordan, and he's from Eastern PA. And the thing that he thought of to share was that the singer Pink was from his hometown. So that was cool. Some students saw that, and Brennan entered that he is from Nashville, Tennessee, and Taylor Swift went to one of the nearby high schools in Nashville. Another student has a little bit different musical tastes. She's from Winchester, Virginia, and she is from the hometown of Patsy Cline. And then I had another student from Western PA who wanted to point out that the drummer from the band Kuhn is from her hometown. So I had a lot of interesting responses. Not all of them were related to music, obviously, but these were just some of the ones where I could definitely tell that the students were looking at what each other were posting, and they were trying to interest each other. Other uses of Survey123, some of the other speakers have pointed out how you can take Survey123 data and put it into a dashboard, which allows you to view your data visually and also interact with it. I can also do that with my data. I just have a really straightforward example of that. So here's my map of survey responses. Again, the colored dots are the different majors. And I am also able to make a pie chart of the same data to just show the breakdown of students. If you click on different slices in the pie chart, for example, I just clicked on recreation parks. I had 3 students from that major, and the brown dots on the map are where they are from. The wildlife and fisheries students, those are by far the largest component of my students, and the red dots on the map show where the wildlife and fisheries students are from. So by integrating this in the classroom, I was able to show them how to collect really simple data and also how to use the data. So hopefully it was a good example for them. So that was in my online class. I've also used Survey123 in my live class. I've given when I'm teaching in person with the students right in front of me. So this was obviously in previous semesters, but I set up the survey and the map ahead of time. And then I give out the URL or the web link to the survey to the students. And then I show them the map at the end of class so they can see what the responses were like. This works fairly well. It's a good example of collecting data and then mapping it using web mapping. One of my tips that I found from this was definitely to send the URL for the actual survey to the students ahead of time so that all they have to do is click on it. If students have to copy down a URL onto their phones, no matter how short the URL is, there's always going to be mistakes and 10 million questions. And so it's a lot easier to just send it to them ahead of time. I've also used Survey123 outside of the classroom. As you've seen with other examples, I've used it for collecting data from the public. One example was a community needs survey. This was done for extension for the Mon Forest Towns project. They wanted to collect point locations from the towns for recreation related improvements. For example, here's a location where the town would like to have a parking lot for a trail system or better signage for a trail system. And so the advantage of this collecting data in this way, I don't have to assume any level of GIS knowledge, and no GIS account information is needed, no sign-in is needed for the respondents. They just need the web address for the survey. We've also used surveys to collect data for a web application called the West Virginia Local Foods Finder that I did with Extension. This was a survey that was given out to farm producers around the state as COVID was starting. And it was a Qualtrics-based survey because the survey was a little more complex, but we collected data on producers, where they're located in the state and what kind of services and products they provide, and also their hours of service and forms of payment that they accept, things like that. And then we presented the data that was collected through the survey using ArcGIS Online. So my takeaway message, just with these really simple examples of using Survey123 and other types of surveys, is that surveys can be really quick, useful ways to collect and present spatial data for different audiences. You can do a survey where you set up the survey and give it out as an assignment, or you can actually set up a survey and give it out live during a presentation or during a class. Both work fairly well. These capabilities are pretty straightforward to use. You can set them up fairly quickly using most levels of ArcGIS Online subscriptions. And you can check it out if you search for Survey123 for ArcGIS, or the new Field Maps app from Esri also contains these capabilities as well. So that's all I had to talk about. If anyone has any questions on how I've used Survey123 and related applications, I'd be happy to answer them now. I also understand I'm the last speaker between everybody in a short break, so I can take questions by email as well.
Jackie, thanks. We have plenty of time for questions. I'm actually the next speaker after the break, and mine is going to be really short, so we'll have plenty of time. So if there's any questions for Jackie.
Okay, thanks everyone.
Thanks, Jackie.
Perfect. Okay, well, taking a look at the clock and the schedule, Kevin, would you be okay starting about 5 minutes later than scheduled to give everybody until 3:55 to break and then come back?
Sounds perfect.
Okay, folks, well, we're going to stay right here in this room unless you want to swap over into the other presentation track. But I'm going to go radio silent, and we'll all come back here and begin the next set of presentations at 3:55. Okay, I have 3:55, so let's go ahead and get started back up again. Kevin, you look like you're ready, so take it away.
All right. I'm confused. Are we, oh, I might be in the wrong session. Okay. Is everybody back? Good afternoon, everybody. Just in case you didn't know, my name is Kevin Kuhn. I'm a GIS analyst and outgoing president of the WVAGP for the GIS Technical Center. So this session is going to go by really quick. All I wanted to do is the Tech Center, wanted to give you guys just an update on some of the maybe most commonly accessed or accessible data sets that we have. So I'm going to go through just a couple slides that give you a status graphic and then also give you a chance to ask us questions. So if you have questions for me or the Tech Center, we can go through those, but it'll be quick, promise. So two things that I do not have a slide for per se, but one would be the addressing data. So that's going to be your site address points, your building centroid point, and then the associated road center line. That data set is coming from the SAMB system, SAMS2, SAMS. So that's something that we are co-data stewards with the Emergency Management Division at the state, and then also all of the county addressing 911 addressing offices. So typically we get updates annually or biannually from most counties. That data is assimilated into a single statewide data set. And then we turn around and then provide that both as a service that you can accessible through our REST services, and then also from the geocoding services that are on some of our applications. And then we also provide a static copy, if you will, that's available to download. And that download, that does get updated periodically. It just depends on when we receive data. So I believe right now it was updated a couple months ago, but we are just about ready to do a new update for that. So if you are looking for addressing data, it is on the clearinghouse. If you have trouble finding it, feel free to give me a call or shoot me an email and I'll direct you to that. Or even better, we can make sure that you get a new version, a new copy of it with the latest data. Okay. Second thing I'll mention is the cadastral data. So the parcel data set, we have a statewide parcel data set that we partner with the West Virginia State Property Tax Division, who in turn also works with all of the individual counties, county assessor offices, to provide parcel geometry and also the IAS integrated assessment system records for the entire state. That is additional data set that feeds into all kinds of our applications, most noticeably the West Virginia Property Viewer, and then also the Flood Tool and other applications as well. In addition to those applications, we also do make that data available for download as well, so that the public can access that data. We just received the brand new 2021 tax year data last week. So Ebing and I have started to process that data. It'll probably take us a week or two to get that data back up and integrated into all of our applications. And then also available on the clearinghouse for download, but you should be able to see that in a couple weeks, maybe mid-July. If you have questions about that as well, I would be the contact for the cadastral data. Feel free to shoot me a line if you have questions about that. Some of the other application, or excuse me, some of the other development, data development projects we've been working on. So if you're familiar with our work at the Tech Center, we have been pretty deep into a hazard mitigation grant project. That's at HMGP, funded by FEMA, sponsored by the Emergency Management Division. And we have been working with the county floodplain managers, municipal floodplain managers, and a whole host of other people to work out several hazards. So specifically flooding, as you are all aware of, is endemic in this state. And then also the landslides, which Aaron Maxwell just gave a talk on in the other track. Part of that project, we have undergone extensive data development. Maybe most noticeably to most of you have been the aerial photography. FEMA, along with the counties, have allowed us to contract at kind of volume pricing with Thrasher to acquire photography. This, I wanted to make very clear that this is the last year, this coming year is the last year that you can get underneath the contract pricing. So if you know of a county or entity that is interested in flying photography, please contact us as soon as possible so that we can make sure that you're on the radar to get flown over the coming winter. I believe this is going to be the last year for that as far as we know. So I'll give you a quick status graphic of the current counties. Just a real quick mention, the HMGP project also supported addressing data development in a number of counties and cadastral mapping in a number of counties as well. And we are just now, as of this week, receiving final deliverables for the entirety of that project. So it has been a 3-year process of getting new data for various counties, and our contractors have done an excellent job so far, and we're really happy. We've received a lot of good positive feedback from the clients on the data side, so it's been a pretty large success in my humble opinion. Okay, moving through real quick. There have been service updates. Unlike publishing a static data set to our clearinghouse, we are constantly updating a lot of our services. So it may be under the same address, but that doesn't mean that things are changing behind the scenes. Parcels and addresses would be good examples of those. Those services are constantly being updated. Well, addressing is constantly being updated. Parcels are updated about once a year, but those are about to again be updated. We did just publish 2 new services. Even published the land cover service. This was a request. Oh man, I can't remember who requested it, but we had a request from another agency to make available some of the land cover data sets as a service. So we were able to get that up and running for them. I'll mention that if you have data or see something on our clearinghouse that you guys would like to see published as a service, drop us a line, let us know, and we'll see if we can help you out, okay? Service address is at the bottom, services.wvgis.wvu.edu. If you're not familiar with it, again, it's on our website, or if you know how to contact me, if you're not familiar where it is, you can do that as well. So the first couple status graphics are going to be aerial photography. This is the current aerial photography except Pendleton County. So Pendleton County, we had tried to fly for 3 years, I believe. And every year we were not able to fly them due to either snow cover, leaf cover, or high water. And I think this year was the final year that we were able to do it. And they were #1 on our priority list to fly, and finally got Pendleton flown. So you can see what we were doing here is actually trying to eat at the Sheriff's Association imagery that had been the base map for the better part of 10 years. So that was flown in 2010. We are finally able to replace all of that imagery with the goal of trying to get everybody up to date within at least the last 5 years. So you can see the status of where everybody's at now, and then also got a year acquired map as well. So you can see that we're pretty much within our 5-year tolerance now. All right, so this is all going to be underneath our services for best leaf off imagery service. Another quick update for the elevation data. So this is another data set that we have been working on specifically with FEMA. I know a lot of you have expressed interest in the LiDAR data deliveries from FEMA. Their contractors have been hitting snags, mostly, from my understanding, is due to the pandemic, but they expect final data delivery of the fall for 2021 for the LiDAR. I believe that's all been flown. It is in processing, and I believe some of it has even gone through QC and is in our final edits right now. With that, there is also available contours from this data. And my boss wanted me to stress that if you are trying to build surfaces to, where possible, use the contours and break lines, not directly the LAS data. Break lines will provide better details for your topography. So this is a status graphic of the source for the LiDAR data. I'll just quickly have this on screen so you can take a gander at who is providing what. And then I will also click through the next one, which is going to give you anticipated processing dates. You can see that the pink-ish areas were all 2018 collected or thereafter, and then also processed within expected at the time of late 2020, early 2021. Those are all going to be, or should be now, 2021 delivery dates. So we anticipate receiving those hopefully within several months, is what we understand. Once we get these, we will process them as well back into that Hillshade, and then also make the data available on map.wv.gov/elevation or map.wv.gov/LiDAR, which is the same site. We also have been working continuously on some of the flood data, as some of my colleagues in the other session have been talking about today. That includes some of the REST services. So again, this is one of those data sets that, if you didn't know any better, they're being updated constantly with fresh data as we get them from the restudies from FEMA restudy areas. Then we integrate them back into the data sets. So those are things that are being updated pretty regularly. Somewhat related to that, this is one of the data layers for landslide points that have been created and published as a service. And our risk map study areas. So these are to be studied revisions to flood zones and the risk map studies. So this is going to be over the next, I believe, year or two, not really sure. Graphic that depicts the status of the HECRAS, water resolution, 1 meter resolution. I cannot remember my terminology today, so I apologize, but if you know what this is, then ask me questions later. Also an updated zone AE. So this is all the counties that have revision to their AE. And I think that was it. And like I said, I think that was a pretty quick slideshow. And if there are any other questions, I'd be happy to answer them now.
All right, perfect. Kevin, thank you so much for that presentation. Up next, we have Jinyang Deng, Wenjing Zeng, and Yongde Zhong. So if that group is ready, please feel free to go ahead and share your screen and go right ahead.
Sorry. Hello everyone, my name is Jinyang Deng. I'm a professor in recreation parks and tourism resources at WVU. So my presentation today is about creation of recreation opportunity spectrum using GIS and big data. So this presentation is based on a research by my Chinese colleague, Dr. Zhong, and his graduate Wenjing from Central South University of Forestry and Technology. A little background on a recreation opportunity spectrum, which is an inventory and planning tool for outdoor recreation resources. It was proposed by USDA Forest Service in the late 1970s. The development of RS is based on the premise that people seek to engage in preferred activities in preferred settings to achieve preferred experience. 3 criteria: physical setting, social setting, and managerial setting are combined together when creating an RS. So a typical RS has 6 classes ranging from primitive to a semi-primitive non-motorized, semi-primitive motorized to a roaded, natural, rural, and urban. The physics setting is measured by 3 indicators: remoteness, size, and evidence of humans. For an area to be classified as primitive, that area must be at least 3 miles away from all roads, with a minimum 5,000 acres without any human modifications. Let me skip those roads and jump to urban. So urban class, so it must be located within half mile from improved roads, could be in any size, and dominated by a developed area like structures. Social setting reflects the amount and type of contact between individuals and groups, indicating opportunities for solitude or interactions with selected individuals or within large groups. So social setting is measured by user density. Managerial setting reflects the amount and kind of restrictions placed on people's actions by the administering agency or private landowner, which in turn affect recreation opportunities, is measured by managerial regimentation and noticeability. As aforementioned, there are 6 classes for a typical ROS. However, ROS class name and class number could vary depending on the study area. For example, for the New England region, USDA proposed a classification of 8 classes. The first 3 are named the same, but the rest are named differently. Look at the highly developed. It is further divided into 3 sub-classes: large natural, small natural, and facilities. So this standard was followed in this research because Hunan province is quite comparable to the New England region geographically. To study purposes, first, to classify ROS at the provincial level and apply to a Hunan province based on the USDA ROS guideline developed for New England in 2003. Second one is to divide all 122 counties in the province into different levels based on ROS related fact dominance index. So initially, ROS was proposed for USDA National Forest. So its application has been extended to other non-forest dominated settings, such as wilderness areas, water bodies, coast range, suburban mountainous areas. Its application has also been extended to non-federal lands, including all land types, not just limited to forest, national forests, and applied at varying scales at county level, state level, and national level. Moore and associates developed ROS for Vermont. They hope that other states will be interested in adopting ROS for their inventory and planning. However, most studies are still limited to like a forest area. Only a few studies have applied ROS at the state level. So let me show you 3 previous studies at county level, state level, and the national level. First one at county level, conducted by my colleague, Dr. Pierce Keller, and I, with help from Jack Strager. So I want to thank you, Jack, for your help. So we developed an ROS for the Monongahela and Preston counties combined, and we identified 5 classes for the 2 counties combined. So no primitive class was identified for the 2 counties. We also did a study at state level, that's for the whole West Virginia. So we classified the whole state into 5 classes, again, without a primitive class for the state. So the class rural accounted for 80% of the total. So it's the dominating non-use for the state. We also classified all 55 counties into one of 5 levels measuring wild and wonderful based on their ROS naturalness. So as you can see from this map, we have 6 counties in the east ranked as most wild and wonderful. Okay. Finally, we found a study at the national level from New Zealand. That study classified New Zealand into 6 classes: urban, rural, front country, back country, remote, and wilderness. So you can see the name a little different, right? So it reflects the landscape nature and recreational and management practice in New Zealand. Okay, let's look at the study area, Hunan province. Not sure if you have been to China and to this area, Central South. So Hunan province, located over here on the south bank of the Yangtze River. The Yangtze River runs through, goes this way. The area for the province, 81,000 square miles, with a population 67 million. So it is very mountainous, surrounded by mountains and hills to east, south, and west. Here is the Dongting Lake, the second largest freshwater lake in China, about 1,000 square miles. It's normal time, but during the flooding season, the size could be increased to 7,000 miles. Okay, criteria. We applied a physical setting and a social setting to create ROAs for the province. We didn't include managerial setting because of that, because we don't have data. So on the management. So in terms of evidence of humans, we use the big data, light value as a proxy to represent evidence of humans. And we use a point of interest, the density of point of interest as a proxy for user density. Information on roads was obtained from the National Basic Geographic Information Center, and light noise data were obtained from the NOAA's National Centers for Environmental Information. POI data, we got this data from this platform. So Python was used to obtain the latitude, longitude, and name of those public surveys. So as I mentioned, we used the light value as a proxy for evidence of humans. So the annual light value was calculated based on this formula. So it is a average of the sum of the monthly light value for 12 months. And then we are classified into 6 levels. So with smallest value for level 1 and the largest for level 6. Also for user density, we used POI to represent user density. So POI, the POI density was calculated by dividing the number of POI by the area of a neighborhood. We also classified POI density into 6 levels. Level 1, smallest value, to level 6 with largest value. Okay, spatial analysis. We used buffer analysis, overlay analysis, density analysis were combined, and then reclassify into 8 8 classes. In terms of a buffer analysis, we applied 2 miles, not 3 miles, following the New England standard to differentiate primitive from the rest from other classes. This flow chart shows how size criteria can be applied to separate those 3 classes. Okay, normally like 5,000 acres applied for primitive and 2,500 acres applying to semi-primitive non-motorized, semi-primitive motorized. But for this study, following the New England standard, we reduced 5,000 acres to 3,000 acres for primitive and 1,000 for semi-primitive, non-motorized, semi-primitive motorized, lot 2,500. So as I mentioned, right, we can apply different standards depending on the study area. Okay, factor dominance. So we calculated the factor dominance for each RS class for each county based on this formula. It's kind of a weighted sum of the 3 factors, the DPI, relative density of class I, DFI, relative frequency of the class, and relative size of the class. So we calculate this value for each county, each class. We also calculated this value for each class at the provincial level for the whole state. And then we come up with a ratio by dividing the value of the score for the county level, okay, by the score at the provincial level. So we got the ratio. We then apply the maximum ratio value as the dominance level for a county. Okay, results for RS. So as we can see from here, semi-primitive motorized accounted for the largest portion of the land, about 40%. Highly developed accounted for about 1%. In terms of classification of the 122 counties based on the RS dominance, so we had 8 counties with the ratio value corresponding to facilities class. So those 8 counties are classified as K metropolitan counties. Similarly, we have 21 general metropolitan counties, 50 rural counties, 24 general natural recreation resource counties, and 19 K natural recreation resource counties. Look at this map that shows the distribution of the county classes. So for the 8K metropolitan counties, most of those counties concentrated over here. A region with a cluster of 3 big cities. The capital city, Changsha, is around over here. Okay, discussion conclusions. Hunan province is as diverse in RS with semi-primitive accounting for approximately 60% of the total land. So providing a wide array of recreational opportunity for the general public. Findings of this study can inform resource managers and policymakers on the appropriate use and planning of the natural resources in the province. With the advancement of technology and availability of big data, RS can be created in large scale with all land types, not just limited to like a federal land or like forest dominated settings, can be applied to all non-types, private or public, developed or undeveloped. Use of big data in RAs provides an alternative to USDA's recent efforts to use route, density, and level of development to represent evidence of humans. And given the dynamics of physical, social, and managerial settings, GIS can make it easy or convenient to update RAs map at seasonal level. So we can create seasonal maps easily with the application of GIS technology. But like I think before 2003, we have to manually create our ACE map, but now we can create with GIS. Okay, limitations. Use of POI may not reflect actual on-site use. And managerial criteria, as I mentioned, are not used in the creation of the map for the province. So in the future, we may need to get the big data from other platform, like a Baidu heat map, Uber Media, or Streetlight, to get some spatial temporal movement data to know about the visit flow. So this may be better to reflect the actual on-site use for area. Also, we need to develop our management standards and indicators and then incorporate into the creation in combination with the physical setting and the social setting. Okay, so that's pretty much for my presentation. Thank you very much. So I'm ready to take questions. So any questions?
Thank you, Jinyang.
Let me stop sharing. Thank you.
Thank you for presenting for us.
Thank you.
Fantastic. Okay. Well, next up we have Aaron Maxwell. Aaron, are you ready?
Yep, my screen share started. Okay, so I'm Aaron Maxwell. I'm a professor in the Geology and Geography Department of VU. I also work with the Tech Center in the state, and also I work with West Virginia VU, which is what I'm talking about here. So over the last couple years, I guess it's been 4 years, we've been working on developing a series of free open course material courses that we host on our website. So effectively, I'm just going to go through and discuss those courses, what topics are covered, and how they might be useful if you're trying to learn a new skill or want to implement something in a class you teach or for your employees or whatnot. Okay, so before we get started, I just wanted to give you an overview of what West Virginia VU is and how it came to exist. So West Virginia VU was originally ran by Dr. Tim Warner, who recently retired. And prior to his retirement, he phased me in as the new director coordinator. So I took this over about 4 years ago, and he had ran it for a couple decades ahead of me. So West Virginia VU is part of America VU, which is a consortium of state views. So like West Virginia VU, Ohio VU, Hawaii VU, Wyoming VU. And we're funded by the USGS. And the goal is effectively to, at the state level, develop and contribute to remote sensing, outreach, education, and research. So anyway, we're one of the members of America VU, which is, again, the kind of the parent consortium. This is kind of our major objectives. What I'm focusing on here is the development of free and open course and training materials associated with a wide range of geospatial topics and technologies. So I have the website up on the side here. So I'm going to kind of bounce back and forth between the website and the presentation here. Okay, so over the last 4 years, we've developed a series of courses. At this point, we're basically done, and we're just going to hopefully maintain these courses or update them as technologies change or whatnot. We're not hoping to develop a lot of additional material. So right now we have 7 courses. By August, we should have 8. We're working on a deep learning course now, but all the rest of them are posted at this point. Okay, so we also are pretty active on YouTube. We have over 250 videos posted to date on a wide variety of topics. But again, remote sensing, geospatial topics. And this is kind of new, but we're starting to get more active on GitHub. So putting up code for different experiments or examples or use cases. So part of our deep learning course will be a set of code examples for doing different types of deep learning on geospatial data using Python and R. Okay, so I'm just going to do a brief overview of the courses we have, kind of what the goal of the course is and who it's like appropriate for. So Digital Earth is meant to be a very introductory course. It's basically a broad introduction to geospatial technologies, so including GIS, spatial analysis, remote sensing, and GNSS. It's appropriate for generally lower level undergraduates like freshmen, sophomores, but something like this could be used in a high school classroom. If there are high school teachers that are on the call, probably not, but you can get a lot of the like Esri technologies for free in the public schools. So that's kind of the audience, and all of the course materials are available or make use of ArcGIS Pro. Introduction to GIS Science is kind of our bread and butter GIS course. It's supposed to be the gateway course that gets you into more advanced topics. So it's beginner to intermediate level. The first half is basically all related to data issues. So data structures, datums and projections, data symbology, digital cartography, finding data, dealing with data uncertainty and error. And then the back end of the course is a broad overview of different types of spatial analysis. So vector, raster, network, digital terrain analysis, modeling, model builder, spatial stats. I'll show you the page for this course. So this is the drop page for that course. And as you see, these are all the lecture topics. And then we also have a series of 26 labs. They all have associated data, and then just open up, and then a lab that goes along with it. So that's kind of our main GIS course. Another component is we have lab challenges, which are just less guided labs, more open-ended, that relate to the lecture material and lab material. Okay, this is just an example of a flyer. We use this material in our department in our Geography 350 and 550 courses, which serve the same purpose. It's our intermediate kind of gateway course to more advanced courses. Digital cartography just got posted a month and a half ago, I believe. This is supposed to be an intermediate level course focused on presenting data and communicating with maps, both thematic and reference maps. So here are the key topics, map layout design, visualizing data, thematic mapping, working with graphics, labeling and topology, scale and generalization issues, and just general map communication. So technologies that are covered in there are mainly ArcGIS Pro for map design, and then using Adobe Illustrator as a vector graphics editor to do map cleanup and graphic editing. But you could also do a lot of this with QGIS and like Inkscape if you're working in a fully open environment. The client-side WebGIS course is focused completely on client-side technologies. So there's no like server-side component like PHP or SQL. It's effectively broken into 3 parts. So the first part is basically ArcGIS Online and its associated technologies. So things like Web App Builder, the Experience Builder, App Studio, all that stuff. And then the middle of the course is basically a web development class without any real map related component. So there the student would learn HTML for content, CSS for website design, and then Bootstrap to simplify the design and for responsive design, and then the JavaScript for functionality and jQuery to simplify that. And then the back end of the course introduces a couple JavaScript APIs. So we look at the ArcGIS API for JavaScript, and then the Leaflet JavaScript API, which is open source. So this is that course. So again, we have a series, all the courses are lectures and labs or projects. So there's a series of projects related to the different topics there. Okay, and then remote sensing, we actually just launched 2 weeks ago. So it just recently got completed. So this is more of an intermediate course that's, kind of an intro to remote sensing for GIS or geospatial professionals. So the front end is a lot of theoretical stuff about, like surface reflectance and electromagnetic radiation. Then we get into things like image interpretation, image analysis, pre-processing, and then image classification techniques. And then the back end, we look at some other types of data, so like digital terrain data, LiDAR, synthetic aperture radars, thermals, SAR, stuff like that. The labs for this are all written in ArcGIS Pro with a few other add-ons on things like TalDM and FragStats. This is something we struggled with because there's a ton of different software environments, but we decided to go with Pro because it kind of advances off of our other classes, and there's a ton you can do in Pro now. We're trying to limit the number of commercial software packages that a student would need to have access to. Open source GIS science is kind of like our intro to GIS science class, except that it's designed around all open free course materials. Let me open that up real quick. So instead of using Esri's like ArcGIS and Pro and then the associated tools, we mainly rely on QGIS and then other plugins and packages associated with it. So things like GRASS and Saga, Proj, GDAL, Orfeo Toolbox. So the whole front end is doing a variety of general GIS and spatial analysis stuff using QGIS and its associated tools. And then the back end of the course, we do an introduction to Python and SQL. The Python component of this course doesn't make use of ArcPy. It's supposed to be all open source. So we're using the kind of geospatial and data science Python libraries that are free. So things like NumPy and Pandas and GeoPandas and Rasterio. And then the SQL is basically using PostgreSQL, and that's inside of QGIS. Anyway, so that's kind of getting everyone started with working in the open software ecosystem. Open source spatial analytics is a more advanced course that's basically all taught in code, and we mainly use the R environment, so the R data science statistical environment. So a large portion of that class is just doing general data science stuff in R. So for example, data cleaning, data prep, up here. And then so that's the front end. And then we get into data visualization, like making maps and graphics, working with geospatial data in R specifically. And then the back end, we look at some spatial modeling. So this is an example. I'll pull up one of the lectures here. So this is visualizing spatial data. We're basically making map layouts using TMap, which is an R package. So you can kind of see what the lectures are laid out like. So the technologies that we mainly cover there is obviously R, RStudio, which is an IDE for our integrated development environment, and then Markdown, so taking your data, your results and rendering that out to like web pages or PDF files or something. We also look at using Leaflet in R, so you can generate leaflet maps in R as opposed to using the JavaScript API to make interactive web maps. And then just generally working in the tidyverse, which is a bunch of packages that are used for data manipulation and data visualization that are applicable to spatial data or other things. And our last course that we're currently working on that we should have up by August is this geospatial seminar, which is a little shorter. but it looks at some use cases of deep learning and the geospatial sciences to things like, land cover mapping or object detection. And that's, again, mainly in code. It's Python, PyTorch, and R for the most part. And again, that should be up by August. Our goal is to basically maintain these at this point. So we will have in August 8 courses. Over the next year, we're going to be doing a spot check and revamp of all the courses, updating labs for software changes. But we hope to maintain this long term. And we hope that it's a valuable resource, not just for like college students or people in our own classes, but it could be used by professionals and people that want to learn on their own. That's kind of the whole point, supporting the mission of America View and West Virginia View. So anyway, there's my contact information, and that's all I had.
Fantastic. Does anybody have any questions for Aaron? Well, thank you so much for presenting. That was incredibly, that was a lot of information to share. And if anyone isn't currently registered for Aaron's workshop in the morning, please feel free to do so. But this is going to wrap up day 1 of the WV GIS Conference 2021. Please take a look at tomorrow's schedule. We'll begin with workshops at 9 a.m. And if you still need to register for one of those sessions, or if you'd like to swap, just log into your event hub and you can make those changes to your schedule. But with that, I'm just gonna wish everyone a fantastic day, and we will see you all again in the morning.